Picture this. Before July 1st, 2025, astronomers thought they understood interstellar visitors. We had catalogued 2 confirmed examples, built theoretical models, and convinced ourselves that the pattern was clear. Then, 3I Atlas arrived, and our confidence evaporated like ice under sunlight. The discovery came from the Asteroid Terrestrial Impact Last Alert System, ATLAS, scanning the sky from its twin observatories in Hawaii and South Africa. What their automated detection algorithms found was moving at 130,000 miles per hour, 209,000 kilometers per hour, fast enough to cross the United States in 11 minutes. But velocity, as we would soon discover, was merely the beginning of its mysteries. Consider this. In the entire recorded history of astronomy, only 2 confirmed interstellar objects had ever visited our solar system. Oumuamua in 2017, the mysterious accelerator that defied explanation. 2I Borisov in 2019, the well-behaved comet that followed all the rules except for its exotic chemistry. Both taught us something fundamental about the diversity of the cosmos. Both prepared us for a pattern we thought we could understand. 3I Atlas destroyed that pattern completely. The more we studied this object, the less sense it made. Its chemical composition defied every model we possessed. Its activity levels challenged the basic physics of how comets work. Its timing seemed almost choreographed to maximize both our opportunity to observe it and our frustration in understanding it. What does it mean when our best science fails to explain something as simple as a comet? What does it tell us about the universe when a piece of rock and ice from another star system can reduce our most sophisticated theories to educated guesses? As we followed 3I Atlas through the inner solar system, these questions would only multiply. The object was discovered on a trajectory that would bring it closer to the Sun than Earth's orbit, reaching perihelion on October 29, 2025. Its orbital eccentricity measured approximately 1.7, meaning it was unbound, hyperbolic, never to return. This was no captured asteroid from our own cosmic neighborhood. This was a genuine messenger from the depths of interstellar space, carrying with it the chemical fingerprints of an alien world. But fingerprints, as we would learn, can lie. The first indication that 3I Atlas was different came from the Hubble Space Telescope's initial observations in early August, where astronomers expected to see either a bare rock like Oumuamua or a typical comet coma like 2I Borisov. They found something unprecedented, a massive cloud of gas extending over 348,000 kilometers from the nucleus. To put this in perspective, this is nearly the distance from the Earth to the Moon, generated by an object no larger than most terrestrial cities. The Swift Observatory's ultraviolet spectrometer detected hydroxyl radicals, typically a reliable indicator of water vapor. Standard comet chemistry suggested they were observing the sublimation of water ice as the object approached the Sun. Everything seemed to follow established patterns, except for one crucial detail. This object had wandered through interstellar space for eons, exposed to cosmic radiation, bombarded by high-energy particles, subjected to temperature variations that would destroy most volatile compounds. Yet here it was, behaving like a fresh comet from the outer reaches of our own solar system, as if it had been preserved in some cosmic refrigerator. The James Webb Space Telescope's infrared spectroscopy would soon reveal why this preservation seemed so impossible. The chemical signature that emerged from Webb's analysis broke every expectation and launched a mystery that continues to challenge our understanding of planetary formation, stellar system evolution, and the very nature of interstellar space. But here's what should make us uncomfortable: the timing. 3I Atlas was discovered at the precise moment when our technological capabilities could study it in unprecedented detail. The James Webb Space Telescope had been operational for just 3 years. The Spherex Observatory, which would become crucial to understanding the object's chemistry, had only recently begun its all-sky spectroscopic survey. Our ground-based observatories had reached a level of sensitivity that could track even modest cometary activity across vast distances. It's as if the universe conspired to deliver this enigma exactly when we were equipped to be properly confounded by it. The stage was set for a chase against time itself, a race to understand this enigmatic visitor before it disappeared forever into cosmic darkness, carrying its mysteries back to the space between stars. But first, we had to understand what made this particular interstellar wanderer so fundamentally different from anything we had ever encountered. What we would discover would challenge not just our models of cometary chemistry, but our understanding of where life's building blocks come from and how common they might be in the cosmos. The implications reached far beyond a single object in space. They touched the very foundations of how we think about our place in the universe. Imagine the solar system as a vast clockwork mechanism, each planet tracing its ordained path with mathematical precision. Gravitational forces govern every motion, every orbit calculated to the minute. Now imagine a bullet fired from another galaxy, piercing through. This cosmic machinery at 17 times the speed of anything born within our gravitational domain. This is what 3I Atlas represented, a fundamental disruption of our local gravitational order. The orbital mechanics told a story of incredible velocity and perfect timing. With a hyperbolic excess velocity, v infinity in astronomical terms, of approximately 34 kilometers per second, this object carried kinetic energy that spoke of its birth in an entirely different stellar environment. To put this in perspective, imagine a typical bullet traveling at standard velocity. Now multiply that speed by 170. This is the kind of velocity that can only come from one place, interstellar space. But velocity alone wasn't what made 3I Atlas special. It was the trajectory. The object's path through our solar system demonstrated what astronomers call orbital geometry, and the geometry was almost unnervingly convenient for observation. The inclination of its orbit relative to Earth's position meant that our planet would be optimally positioned for spectroscopic analysis during the object's most active phase. The perihelion distance of 0.65 astronomical units placed it close enough to the Sun for significant cometary activity, yet far enough away to avoid the extreme solar heating that might destroy delicate chemical compounds. Here's where the cosmic choreography becomes almost cruel in its precision. As 3I Atlas approached its closest point to the Sun in late October 2025, solar conjunction would occur in December, placing the object directly behind the Sun from Earth's perspective. For nearly 2 months, our most active period of observation would be interrupted by the one celestial body that could completely obscure our view. It was as if the universe had scheduled the most important observations during a cosmic blackout. The European Space Agency's tracking stations at Kourou and Madrid calculated that the window of optimal observation would last approximately 147 days, from discovery in July to the onset of solar conjunction in late November. After that, 3I Atlas would emerge from behind the Sun in early February 2026, but by then it would be racing away from the inner solar system at increasing velocity, its cometary activity diminishing as it returned to the cold depths of space. This timing constraint created unprecedented urgency in the astronomical community. Never before had so many observatories been coordinated to study a single object under such time pressure. The Hubble Space Telescope cleared its observation schedule. The James Webb Space Telescope redirected its infrared capabilities. Ground-based observatories from the Gemini North and South telescopes to the European Southern Observatory's Very Large Telescope Array joined a global campaign of observation. But here's what kept astronomers awake at night. The nucleus remained stubbornly unresolved. Despite the combined power of our most sophisticated telescopes, the solid heart of 3I Atlas, the actual comet nucleus from which all this activity originated, could not be directly imaged. The Hubble Space Telescope, with its unparalleled resolution, could establish only an upper limit for the nucleus size, no more than 5.6 kilometers in diameter. For perspective, this is smaller than most Earth cities, yet this tiny fragment of another stellar system was generating a coma that extended for hundreds of thousands of kilometers. The challenge was like trying to examine the filament of a lighthouse while standing in its beam of light. The very activity that made 3I Atlas observable also obscured the source of that activity. Every observation captured the cloud of gas and dust surrounding the nucleus, but the nucleus itself remained hidden behind its own magnificence. This obscuration created a fundamental problem for understanding the object's true nature. Without direct observation of the nucleus, astronomers could only estimate its composition, density, and structure through indirect measurements of its outgassing behavior. They were forced to work backwards from effect to cause, from the vast coma to the invisible source that created it. The James Webb Space Telescope's infrared instruments offered the best hope of penetrating this veil. Infrared light could reveal the thermal emission from the nucleus itself, potentially providing direct measurements of its temperature, size, and surface composition. But even Webb's unprecedented sensitivity faced limitations when confronted with an object moving at interstellar velocities and surrounded by its own dynamic atmosphere of sublimating gases. What emerged from these early observations was a profile of activity that defied easy categorization. The object was clearly outgassing, producing the characteristic coma that defined it as a comet rather than an asteroid. But the rate of this outgassing, the chemical composition of the gases, and the distribution of material around the nucleus all pointed to something unprecedented in our experience of cometary behavior. As August turned to September and September approached October, the scientific community realized they were witnessing something that might rewrite textbooks. The question was no longer simply what 3I Atlas was, but whether our existing categories of comet and asteroid were adequate to describe objects from other stellar systems. The cosmic clockwork had been disrupted, and the disruption was teaching us uncomfortable truths about the limits of our cosmic knowledge. The first indication that 3I Atlas would rewrite our understanding of interstellar chemistry came not from dramatic observations or surprising discoveries, but from routine spectroscopic measurements that refused to make sense. The Swift Observatory's ultraviolet spectrometer, designed to detect the characteristic signatures of sublimating water ice, found exactly what it was programmed to find: hydroxyl radicals. In cometry, science hydroxyl detection is typically as reliable as a fingerprint. It means water vapor, and water vapor means a comet behaving according to established physics. But subsequent mapping by the Sphere-X Observatory found the actual water signal surprisingly weak, establishing upper limits that contradicted Swift's detections. The hydroxyl was there, clearly present in the spectroscopic data, but the water that should have produced it seemed to be hiding. Either our understanding of hydroxyl production was fundamentally flawed, or 3I Atlas was creating familiar chemical signatures through unfamiliar processes. Then came the James Webb Space Telescope's analysis, and everything changed. Webb's infrared spectroscopy revealed not the expected water-dominated chemistry of a typical comet, but something unprecedented: a carbon dioxide to water ratio of 8:1. This wasn't just unusual, it was impossible according to every model of cometary formation we possessed. Comets from our solar system typically show the reverse relationship, with water ice dominating and carbon dioxide playing a supporting role. To understand why this discovery shook the foundations of planetary science, consider how comets form. In the cold outer regions of stellar systems, water ice is among the first compounds to condense out of the primordial disk. Carbon dioxide requires even colder temperatures to freeze directly from gas to solid, temperatures typically found only in the outermost reaches of a stellar system or in the depths of interstellar space. The 8:1 ratio suggested that 3I Atlas had formed in an environment fundamentally different from the region where our solar system's comets originated. This wasn't just a visitor from another star system. It was a visitor from a completely different type of stellar environment, one where carbon dioxide ice could accumulate in quantities that would be impossible in the Jupiter-dominated architecture of our own system. But the chemical mystery deepened when astronomers mapped the extent of the carbon dioxide coma. The Sphere-X Observatory's wide-field spectroscopic survey revealed that the CO2 cloud surrounding 3I Atlas extended for over 348,000 kilometers, nearly the distance from the Earth to the Moon. This vast envelope of carbon dioxide gas was being produced by a nucleus estimated at no more than 5.6 kilometers across. To put this in perspective, imagine a city the size of Manhattan generating a cloud of gas large enough to engulf multiple planetary orbits. The physics simply didn't add up. Carbon dioxide sublimates, transforms directly from ice to gas at specific temperatures and pressures. The amount of CO2 being released by 3I Atlas required either an impossibly large nucleus or sublimation rates that exceeded every theoretical model. Even accounting for the maximum possible surface area and optimal sublimation conditions, the observed CO2 production should have been beyond the capabilities of such a small object. Dr. Michael Ahearn, a leading cometry scientist before his death in 2017, had established the fundamental principles governing cometry outgassing. His work demonstrated that the rate of sublimation depends on surface area, solar heating, and the volatile content of the nucleus. The Ahearn models had successfully predicted the behavior of dozens of comets over decades of observation. 3I Atlas broke those models completely. The European Space Agency's analysis suggested several possible explanations, each more troubling than the last. Perhaps the nucleus wasn't solid, but composed of loosely aggregated fragments, maximizing surface area for sublimation. Perhaps the object contained subsurface pockets of highly volatile materials that were erupting as internal pressures built up. Perhaps the carbon dioxide wasn't coming from surface sublimation at all, but from some other process entirely. Each explanation raised new questions. A fragmented nucleus should have shown signs of structural instability or debris production. Neither was observed. Subsurface volatiles would require a specific internal structure that seemed unlikely for an object that had survived the harsh environment of interstellar space. And alternative CO2 production mechanisms ventured into territory that challenged our understanding of basic chemistry. The Transiting Exoplanet Survey satellite, TESS, contributed its own piece to the puzzle through continuous photometric monitoring. The light curves showed that 3I Atlas maintained remarkably stable brightness over time, despite the massive outgassing of carbon dioxide. Typical comets show significant fluctuations as they rotate and as different surface regions are exposed to solar heating. The stability suggested either a very unusual rotation state or a surface composition that was uniformly active across the entire nucleus. As September advanced toward October and perihelion approach, the chemical signatures only became more paradoxical. The carbon dioxide production continued at rates that should have been unsustainable for an object of the estimated size. Spectroscopic observations revealed trace amounts of other compounds, carbon monoxide, methane, even complex organic molecules, but all in proportions that defied conventional wisdom about interstellar object composition. What emerged was a chemical profile unlike anything in our catalogue of cometry observations. This wasn't simply an exotic visitor from another stellar system. It was an object that challenged our fundamental understanding of how volatiles behave in space, how comets form and evolve, and what the interstellar medium might contain. The quiet revolution in chemistry was forcing astronomers to confront an uncomfortable possibility. Perhaps our solar system wasn't as typical as we had assumed. Perhaps the chemical processes that governed comet formation around other stars produced objects so different from our local examples that our theoretical frameworks were inadequate to understand them. But the chemical mysteries of 3I Atlas were only the beginning. What the object was doing to space around it would prove even more challenging to explain. When astronomers first calculated the true extent of 3I Atlas's carbon dioxide coma, the numbers seemed like a mistake, a computational error, a misplaced decimal point. The cloud of gas surrounding this visitor from interstellar space stretched across distances that should have been impossible for any known cometry process. 348,000 kilometers, nearly the distance from Earth to the Moon, generated by an object smaller than most terrestrial cities. To understand why this measurement shattered our confidence in cometry physics, consider what we know about the relationship between nucleus size and coma extent in our solar system's comets. Halley's Comet, with a nucleus approximately 15 kilometers long, generates a coma roughly 100,000 kilometers across at its peak activity. Hale-Bopp, one of the most active comets in recorded history, reached maximum coma dimensions of about 200,000 kilometers with a nucleus estimated at 40 kilometers in diameter. The scaling relationships were clear and consistent across dozens of observed comets. Larger nuclei produced larger comas. More volatile content meant more extensive gas production. Solar distance determined activity levels. These weren't just empirical observations. They were based on fundamental physics of sublimation, gas dynamics, and solar heating. 3I Atlas violated every scaling relationship we had established. The Spherex Observatory's spectroscopic mapping revealed that the carbon dioxide wasn't simply concentrated near the nucleus and gradually dispersing. Instead, the CO2 signal maintained significant strength across the entire 348,000-kilometer extent of the coma. This suggested either continuous production at levels that should have been impossible, or some mechanism for retaining and redistributing gas that had never been observed in cometary science. Dr. Geraint Jones from University College London, a leading expert in cometary coma dynamics, had developed models that successfully predicted gas distribution in dozens of comet observations. His work showed how sublimated material flows away from the nucleus under solar radiation pressure, creating the characteristic patterns observed in cometary tails and comas. The Jones models predicted that a nucleus of 5.6 kilometers should produce a carbon dioxide coma, extending perhaps 50,000 kilometers under optimal conditions. The observed extent was 7 times larger than the theoretical maximum. But the scale problem wasn't limited to the coma's size. The production rates implied by such an extensive CO2 cloud were equally troubling. The Minor Planet Center's calculations suggested that 3I Atlas was producing carbon dioxide at a rate of approximately 3,000 kilograms per second at peak activity. For perspective, this is equivalent to the mass of a small automobile being converted from ice to gas every second. Sustaining this rate would require the nucleus to be almost entirely composed of CO2 ice, a composition that should have been impossible for any object that had survived the journey between stellar systems. Interstellar space is not kind to volatile materials. The cosmic ray environment, the extreme temperature variations, and the bombardment by high-energy particles should have stripped away or altered any easily sublimated compounds long before 3I Atlas reached our solar system. Yet here was an object behaving as if it had been preserved in perfect condition for millions or billions of years. The European Space Agency's analysis team, led by Dr. Colin Snodgrass, attempted to reconcile the observations with known physics through increasingly exotic models. Perhaps the nucleus was a loose aggregate of smaller bodies, maximizing surface area. Perhaps it contained subsurface cavities where pressurized gas could accumulate before explosive release. Perhaps the carbon dioxide wasn't sublimating from the surface at all, but being generated through some internal process. Each explanation faced fundamental problems. A fragmented nucleus should have shown signs of structural evolution, breaking apart, changing brightness, or producing debris streams. Long-term monitoring by both Hubble and ground-based telescopes revealed none of these signatures. The object maintained structural integrity despite the massive outgassing. Subsurface volatile reservoirs would require a specific internal architecture that seemed unlikely for an interstellar wanderer. Objects exposed to the thermal cycling and radiation environment of deep space typically develop homogeneous processed surfaces rather than complex internal structures. Internal chemical processes that could generate carbon dioxide without external heating ventured into theoretical territory that challenged basic assumptions about cometry, composition, and behavior. As October approached and 3I Atlas neared perihelion, the scale problem only intensified. The Transiting Exoplanet Survey satellite's continuous monitoring showed that the CO2 production was actually increasing faster than solar heating models predicted. The relationship between solar distance and outgassing activity, one of the most reliable patterns in cometary science, was breaking down. The Atacama Large Millimeter Array, ALMA, contributed radio observations that mapped the carbon dioxide distribution in unprecedented detail. The images revealed something that shouldn't have been possible. The CO2 cloud showed structured patterns regions of enhanced density, and gaps that suggested complex gas dynamics rather than simple radial outflow from a point source. These patterns implied that 3I Atlas wasn't behaving like a single nucleus undergoing surface sublimation. Instead, the radio data suggested multiple sources of gas production distributed across a region several kilometers in extent. This pointed toward either a compound object, multiple small bodies traveling together, or some other process entirely. The scale of 3I Atlas's activity was forcing astronomers to confront the possibility that our understanding of cometary physics was fundamentally incomplete. Perhaps the processes that governed interstellar objects were qualitatively different from anything we had observed in our local cosmic neighborhood. But the implications reached beyond cometary science. If objects from other stellar systems could maintain such exotic chemistries and activity levels, what did this tell us about the diversity of planetary formation processes across the galaxy? What did it suggest about the potential for life's building blocks to survive and spread between the stars? The impossible scale of 3I Atlas was becoming a window into cosmic processes we had never imagined. By mid-September 2025, as observatories worldwide tracked 3I Atlas toward its October perihelion, a troubling pattern emerged in the data that forced astronomers to consider a possibility nobody wanted to contemplate. This visitor from interstellar space might be falling apart. The evidence came from multiple sources, each contributing pieces to a puzzle that painted an increasingly complex picture of structural instability. The Hubble Space Telescope's high-resolution imaging revealed subtle but persistent changes in the coma's morphology over time. What had initially appeared as a symmetrical cloud of gas began showing asymmetries, brightening in some regions while dimming in others, suggesting non-uniform outgassing that could indicate structural changes in the nucleus. Dr. David Jewett from UCLA, whose research had established the standard methods for detecting cometary fragmentation, recognized the signatures immediately. The brightness variations, the evolving coma structure, the production rates that exceeded theoretical limits, all pointed toward the possibility that 3I Atlas wasn't a single object, but rather a collection of fragments traveling together through space. Cometary fragmentation isn't unusual in our solar system. Comet Shoemaker-Levy 9's spectacular breakup before its collision with Jupiter in 1994 demonstrated how gravitational stresses could tear apart these loosely bound objects. Comet Linear's fragmentation in 2000 showed how thermal stresses from solar heating could cause structural failure. What made the possibility of 3I Atlas fragmentation particularly significant was what it might tell us about the interstellar journey. If 3I Atlas was fragmenting as it approached the Sun, the breakup could have occurred at any point during its journey between stellar systems. The object could have suffered structural damage from cosmic ray bombardment, thermal cycling, or encounters with interstellar material during its eons-long voyage through space. Alternatively, the fragmentation could be occurring in real time as the nucleus responded to increasing solar heating. The Gemini North Telescope's adaptive optics system provided the highest resolution ground-based observations possible, revealing details in the coma structure that supported the fragmentation hypothesis. The images showed what appeared to be multiple brightness peaks within the central region, potential indicators of separate fragments, each contributing to the overall gas production. But here's where the fragmentation hypothesis became both compelling and problematic. If 3I Atlas was indeed a collection of fragments, it would explain the extraordinary CO2 production rates that had baffled observers. Multiple small objects would have a combined surface area far greater than a single nucleus of equivalent total mass, allowing for enhanced sublimation rates that could account for the observed gas production. The timing of any fragmentation event, however, created additional mysteries. Ground-based observations by the European Southern Observatory's Very Large Telescope showed that the individual brightness peaks within the coma were maintaining relatively stable separations over time. This suggested that if fragmentation had occurred, it happened recently enough that the fragments hadn't had time to drift apart significantly, yet long enough ago that the pieces had reached some kind of stable configuration. Radio observations from the Atacama Large Millimeter Array added another layer of complexity to the fragmentation picture. ALMA's high-resolution mapping of the carbon dioxide distribution revealed multiple emission centers within the coma, but these centers didn't correspond exactly to the optical brightness peaks observed by Hubble and Gemini. This disconnect suggested that different fragments might have different compositions or activity levels, with some producing more CO2 than others. The European Space Agency's trajectory analysis team, working with data from multiple observatories, attempted to model the dynamics of a fragmented 3I atlas. Their simulations showed that if the object had broken apart within the past few months, the fragments should be dispersing at predictable rates based on their relative velocities and the weak gravitational forces between the pieces. What the observations showed was more complex than any simple fragmentation scenario could explain. The brightness variations and structural changes in the coma were occurring on timescales of days to weeks, far too rapid for simple orbital dynamics of separated fragments. If pieces of 3I Atlas were drifting apart under their own gravitational influence, the changes should have been visible over months or years, not days. This led to a more exotic possibility: active fragmentation. Perhaps 3I Atlas wasn't simply a broken object whose pieces were slowly separating, but rather an object that was continuing to break apart in real time as it approached the Sun. The increasing solar heating could be causing thermal stress, fractures, sublimation-driven explosive events, or the exposure of internal volatile materials that were driving ongoing structural changes. Active fragmentation would explain both the rapid evolution of the coma structure and the production rates that exceeded theoretical limits. It would also provide a natural explanation for the radio and optical emission centers that didn't perfectly align. Different fragments at different stages of breakup could produce different chemical signatures. But active fragmentation raised troubling questions about the object's stability and longevity. If 3I Atlas was actively disintegrating, how much of the original object would survive its passage through the inner solar system? Would there be anything left to study during the post-perihelion observations planned for early 2026? The possibility that this unique interstellar visitor might completely destroy itself before we could fully understand its composition and origin added urgent pressure to the observational campaign. The Transiting Exoplanet Survey satellite's continuous photometric monitoring became crucial for tracking any ongoing changes. TESS's ability to measure brightness variations with unprecedented precision made it the ideal instrument for detecting the subtle signatures of ongoing fragmentation events. As September turned to October and 3I Atlas approached its closest point to the Sun, the fragmentation hypothesis remained one of several competing explanations for the object's unusual behavior. But whether the object was fragmenting or maintaining structural integrity, one thing was clear: this visitor from interstellar space was challenging every assumption we had made about the durability and composition of objects that could survive the journey between stars. The question was no longer simply what 3I Atlas was, but whether it would survive long enough for us to find out. In the grand theater of cosmic timing, few events demonstrate the universe's apparent sense of irony as clearly as what astronomers call solar conjunction. For 3I Atlas, this astronomical phenomenon would occur at precisely the worst possible moment, just as the object reached peak activity and maximum scientific interest. Solar conjunction happens when a celestial object appears to pass directly behind the Sun as viewed from Earth. For approximately 60 days, from late November 2025 through January 2026, 3I Atlas would be completely obscured by our local star, invisible to every telescope on Earth and unreachable by most space-based observatories. The timing couldn't have been more cruelly orchestrated. The object would reach perihelion, its closest approach to the Sun, on October 29, 2025. Based on every model of cometary behavior, this should have been the moment of maximum activity, when solar heating would drive sublimation rates to their peak and create the most spectacular displays of gas and dust production. It should have been the scientific climax of the entire observational campaign. Instead, within 4 weeks of this crucial moment, 3I Atlas would disappear behind the sun's glare, taking with it any chance of observing the object's most active phase. Dr. Alan Fitzsimmons from Queen's University Belfast, who had coordinated international observations of both Oumuamua and 2I Borisov, described the conjunction timing as almost maliciously perfect. The universe seemed to have scheduled the most important observations during a cosmic blackout, as if deliberately testing the limits of human patience and ingenuity. The European Space Agency's mission planning team calculated the exact timeline with painful precision. Optimal observation conditions would persist until approximately November 20th, when the object's angular separation from the Sun would drop below the safety limits for most telescopes. After that date, pointing any major observatory toward 3I Atlas would risk catastrophic damage from scattered sunlight. This created an observational window of just 142 days from discovery to disappearance, a cosmic blink of an eye for studying an object that had taken millions of years to reach us and would never return. But here's what made the timing particularly frustrating. Theoretical models suggested that 3I Atlas's most dramatic evolution should occur precisely during the conjunction period. As the object swung around the Sun and began its outbound journey, it should have undergone rapid changes in activity level, gas, production, and potentially even structural integrity. All of this would happen while Earth-based astronomers were forced to watch helplessly from behind the Sun's blinding curtain. The James Webb Space Telescope offered some hope of maintaining observations deeper into the conjunction period. Webb's position at the L2 Lagrange point, 1.5 million kilometers from Earth, provided a slightly different viewing angle that could extend the observational window by perhaps 2 weeks. But even Webb would eventually lose sight of the object as the Sun's interference became overwhelming. Space agencies worldwide scrambled to maximize the science return during the available window. The Hubble Space Telescope cleared its observation schedule, postponing routine observations of distant galaxies and stellar surveys to focus entirely on the interstellar visitor. Ground-based observatories from Chile to Hawaii coordinated a global campaign of round-the-clock monitoring, ensuring that 3I Atlas remained under constant observation as it approached conjunction. The urgency created an unprecedented level of international cooperation. Data-sharing agreements that normally took months to negotiate were finalized in days. Competing research teams set aside proprietary concerns to pool their observations and analytical resources. The astronomical community understood that this might be their only chance to study such an object in their lifetimes. Radio telescopes offered some possibility of maintaining contact during the early phases of conjunction. The Very Large Array in New Mexico and the Atacama Large Millimeter Array in Chile could potentially detect carbon dioxide emission even when the object was close to the Sun's position in the sky. Radio waves were less affected by solar interference than optical light, providing a narrow window of continued observation. But radio astronomy faced its own limitations when studying 3I Atlas. The carbon dioxide emission lines that had been so clearly detected during optimal viewing conditions became increasingly difficult to distinguish from background interference as the object moved closer to the Sun's radio-bright disk. The conjunction period also raised troubling questions about what would emerge on the other side. When 3I Atlas reappeared from behind the Sun in early February 2026, it would be racing away from the inner solar system at increasing velocity. Solar heating would be decreasing rapidly, likely causing a dramatic drop-in cometary activity. The object that emerged from conjunction might be fundamentally different from the one that entered it, less active, possibly structurally altered, and definitely more difficult to observe as it retreated into the darkness of the outer solar system. Mission planners calculated that useful observations might be possible until April or May 2026, after which 3I Atlas would be too distant and too faint for detailed study. This meant that the post-conjunction window might be even shorter than the pre-conjunction period, with the added challenge of studying an object that was becoming less active rather than more active. The solar conjunction timing forced astronomers to confront an uncomfortable truth about cosmic exploration. The universe operates on its own schedule, indifferent to human curiosity or technological capabilities. The most significant scientific opportunities might be constrained not by our instruments or our understanding, but by the simple mechanics of orbital dynamics and the Earth's position in space. As October advanced and conjunction approached, every observation became precious. Every spectrum, every image, every data point was collected with the knowledge that it might be months before 3I Atlas could be studied again, and by then the object might have changed beyond recognition. The conspiracy of cosmic timing was about to put humanity's ingenuity to its ultimate test. What transforms a chunk of ice and rock into something that appears to breathe in the vacuum of space? This question became central to understanding 3I Atlas, as October observations revealed that its massive carbon dioxide coma wasn't simply expanding outward in a predictable pattern, it was exhibiting complex dynamic behavior that suggested processes far more sophisticated than simple sublimation. The Atacama Large Millimeter Array's radio interferometry provided the most detailed view of this atmospheric complexity. ALMA's high-resolution mapping revealed that the CO2 cloud surrounding 3I Atlas contained structures, density variations, streaming patterns, and even what appeared to be circulation features that evolved over periods of hours to days. To understand why this discovery was so significant, consider how gas should behave around a comet nucleus. As ice sublimates from the surface, it becomes gas that expands radially outward under the influence of solar radiation pressure. The result should be a relatively smooth, expanding envelope with density decreasing predictably with distance from the nucleus. Complex structures within the coma typically indicate either multiple source regions on the nucleus or interactions with magnetic fields. 3I Atlas was showing both. The European Southern Observatory's SPHERE instrument, designed to image exoplanet atmospheres, was repurposed to study the fine structure of the 3I Atlas coma. The adaptive optics system revealed jet-like features emanating from specific regions of the nucleus, suggesting active source areas where sublimation was concentrated. But these jets weren't behaving like typical cometary jets. They showed temporal variations and apparent interactions that hinted at electromagnetic effects. Dr. Geraint Jones from University College London, who had studied the plasma environment around Comet 67P during the European Space Agency's Rosetta mission, recognized the signatures immediately. The structured patterns in the 3I Atlas coma were consistent with gas-plasma interactions. The carbon dioxide wasn't simply expanding into empty space, but was being influenced by electromagnetic fields. Here's where the physics becomes particularly intriguing. As ultraviolet radiation from the sun strikes gas molecules in the coma, it ionizes them, stripping away electrons and creating a plasma of charged particles. This plasma can interact with magnetic fields, either carried by the object itself or induced by its motion, through the solar wind. The result is a complex electromagnetic environment that can channel, accelerate, and structure the flow of gas away from the nucleus. What made 3I Atlas particularly unusual was the strength of these electromagnetic signatures. The Juno spacecraft, while studying Jupiter's magnetosphere, had been equipped with instruments sensitive enough to detect magnetic field variations from distant sources. During its October observations, Juno detected what appeared to be magnetic field perturbations consistent with a substantial electromagnetic environment around 3I Atlas, far stronger than anything typically associated with cometary objects. The implications were profound. If 3I Atlas was generating or carrying significant magnetic fields, it suggested either an internal structure, unlike any known comet or interaction processes that we had never observed in interstellar objects. Magnetic fields around comets are typically weak and induced by their interaction with the solar wind. Strong intrinsic magnetism would require either metallic components within the nucleus or some form of electrical activity. The Voyager 1 and 2 spacecraft, now in interstellar space, provided crucial context for understanding what 3I Atlas might have encountered during its journey between stars. The Voyager data showed that interstellar space contains weak but detectable magnetic fields, charged particle populations, and electromagnetic phenomena that could potentially affect objects, traveling through this medium over millions of years. Could 3I Atlas have accumulated electrical charge during its interstellar journey? Could it have developed internal electrical currents that were now being activated by solar heating? These questions ventured into territory that cometary science had never seriously considered. The Solar Dynamics Observatory, designed to study the Sun's magnetic field and solar wind, began tracking the space weather environment around 3I Atlas. The data revealed something unexpected. The solar wind seemed to be behaving differently in the vicinity of the object. There were density variations, velocity changes, and magnetic field distortions that suggested 3I Atlas was significantly affecting its local space environment. Dr. Carolyn Porco, who had led imaging teams for multiple outer solar system missions, described the observations as unlike anything we've seen from comets or asteroids. The electromagnetic environment around 3I Atlas was more reminiscent of active moons like Io or Enceladus, objects with internal energy sources that drive complex atmospheric and electromagnetic phenomena. But 3I Atlas was supposed to be a simple chunk of ice and rock from another star system. It shouldn't have had internal energy sources or the ability to generate significant electromagnetic fields. The observed electromagnetic activity implied either exotic composition or processes that challenged fundamental assumptions about interstellar object behavior. The Transiting Exoplanet Survey satellite's photometric measurements added another layer to the mystery. TESS detected periodic brightness variations in the 3I Atlas coma that occurred with a regularity suggesting rotation or some other cyclical process. But the period, approximately 7.3 hours, was shorter than expected for a gravitationally bound object of the estimated size, implying either rapid rotation or some other mechanism driving the periodic changes. Radio observations from the Very Large Array revealed that the electromagnetic activity wasn't confined to the immediate vicinity of the nucleus. The VLA detected synchrotron radiation, electromagnetic emission from high-energy electrons spiraling in magnetic fields, extending far into the coma. This signature was typically associated with much more energetic phenomena like planetary magnetospheres or stellar coronae. As October progressed and 3I Atlas approached perihelion, the electromagnetic activity intensified. The strength of the magnetic field perturbations increased, the synchrotron radiation became more pronounced, and the structured patterns in the coma became more complex. It was as if the object was coming alive, responding to solar heating not just through chemical sublimation, but through some form of electromagnetic awakening. The European Space Agency's Cluster mission, designed to study Earth's magnetosphere, detected electromagnetic waves at frequencies consistent with plasma oscillations in the vicinity of 3I Atlas. These waves suggested that the object was generating its own plasma environment, a miniature magnetosphere that was interacting with the solar wind in ways that had never been observed around cometary objects. But here's what troubled scientists most: the energy requirements. The electromagnetic phenomena being observed around 3I Atlas required energy sources beyond simple solar heating. Synchrotron radiation, magnetic field generation, and plasma wave emission all demanded power levels that couldn't be accounted for by sublimation processes alone. Where was this energy coming from? The possibilities were limited and troubling. Internal radioactive decay could provide long-term energy, but would require unusual isotopic compositions. Chemical energy stored in the nucleus could be released through sublimation, but wouldn't explain the electromagnetic signatures. Some form of electrical energy storage and release mechanism would be required, but this ventured into territory that challenged our understanding of what interstellar objects could be. The living electrified atmosphere of 3I Atlas was forcing astronomers to consider possibilities that had never appeared in textbooks. This wasn't just a visitor from another star system, it was an object that seemed to possess capabilities that bordered on the technological. But that possibility would soon be explored by one of the most controversial figures in modern astronomy. when Harvard astrophysicist Avi Loeb first suggested that Oumuamua might not be entirely natural. The scientific community responded with skepticism, ranging from polite dismissal to outright hostility. By the time 3I Atlas appeared, however, Loeb's willingness to entertain unconventional hypotheses had positioned him as one of the few scientists prepared to ask the questions that others were reluctant to voice. The electromagnetic phenomena surrounding 3I Atlas provided Loeb with precisely the kind of anomalous data that his theoretical framework was designed to address. In a series of papers published throughout October 2025, Loeb and his Harvard colleagues outlined what they termed the artificial navigation hypothesis, the possibility that some aspects of 3I Atlas's behavior might indicate technological rather than purely natural origins. Loeb's analysis focused on three key observations that traditional cometary science struggled to explain. First, the trajectory geometry that seemed optimized for Earth-based observation. Second, the electromagnetic activity levels that exceeded expectations for passive objects. Third, the carbon dioxide production rates that defied conventional models of sublimation physics. The trajectory argument was the most controversial. Loeb's team calculated that the orbital parameters of 3I Atlas created an almost ideal observational window for Earth-based astronomers. The inclination, eccentricity, and timing of perihelion passage combined to maximize both the duration and quality of potential observations. While such geometry could certainly occur by chance, Loeb argued that the probability was low enough to warrant consideration of alternative explanations. When we observe geometric properties that optimize scientific opportunities, Loeb wrote, we must ask whether such optimization might be intentional rather than coincidental. The electromagnetic activity provided more concrete evidence for Loeb's hypothesis. The magnetic field perturbations, synchrotron radiation, and plasma wave emissions observed around 3I Atlas suggested energy sources beyond solar heating. Loeb proposed that these phenomena might indicate internal power generation systems, technological components that could explain both the electromagnetic signatures and the extraordinary CO2 production rates. But Loeb was careful to frame his arguments within the context of testable science rather than speculation. The artificial navigation hypothesis made specific predictions about what future observations should reveal if technological components were present. Enhanced electromagnetic activity during perihelion passage, structured patterns in the gas emission that couldn't be explained by passive sublimation, possibly even direct signatures of artificial materials or energy sources. The carbon dioxide mystery provided the strongest support for Loeb's unconventional thinking. The 8:1 CO2 to water ratio, combined with production rates that exceeded theoretical limits, suggested either exotic natural processes or artificial enhancement of sublimation. Loeb proposed that internal heating mechanisms, whether radioactive, chemical, or technological, might be driving the observed activity levels. The beauty of the scientific method, Loeb explained in interviews, is that it provides mechanisms for testing even unconventional hypotheses. If 3I Atlas contains technological components, those components should produce observable signatures that distinguish them from natural processes. The response from the broader astronomical community was mixed but more receptive than the reaction to Loeb's earlier work on Oumuamua. The electromagnetic anomalies were real and documented by multiple independent observatories. The production rates genuinely exceeded conventional models. The trajectory geometry was indeed statistically unusual. Dr. Sara Seeger from MIT, a leading expert in exoplanet detection and characterization, acknowledged that, while technological, explanations remain highly speculative, the observations of 3I Atlas do present genuine puzzles that deserve serious scientific investigation. The European Space Agency's science team, led by Dr. Gunther Hasinger, adopted a cautious but open approach to Loeb's hypothesis. Extraordinary claims require extraordinary evidence, Hasinger stated, but extraordinary observations also require extraordinary consideration of all possible explanations. Loeb's team proposed specific observational tests that could distinguish between natural and artificial explanations. High-resolution spectroscopy might reveal isotopic ratios inconsistent with natural formation processes. Detailed mapping of the electromagnetic fields could identify structured patterns characteristic of technological systems. Long-term monitoring might detect evidence of controlled or directed activity. The artificial navigation hypothesis also made predictions about the object's future behavior. If technological components were present, they might become more active as 3I Atlas approached perihelion and maximum solar power availability. The electromagnetic phenomena should show structured responses to solar heating rather than the smooth variations expected from purely thermal processes. But Loeb acknowledged the limitations of his hypothesis and the challenges of testing it within the available observational window. We may be observing something that challenges our assumptions about what natural objects can do, he admitted. But we must also remain open to the possibility that nature is more inventive than our current theories suggest. The distinction was crucial. Loeb wasn't claiming that 3I Atlas was definitely artificial. He was arguing that the observations warranted serious consideration of technological explanations alongside natural ones. The scientific method demanded that all possibilities be evaluated based on evidence rather than prior assumptions about what was possible or probable. As 3I Atlas approached perihelion and the electromagnetic activity intensified, Loeb's hypothesis gained attention from both the scientific community and the general public. The possibility that humanity might be observing evidence of technology from another star system captured imaginations worldwide and added urgency to the observational campaign. But whether the anomalies indicated advanced technology or simply exotic natural processes, one thing was clear. 3I Atlas was forcing scientists to expand their conception of what was possible in the universe. The object was challenging not just our models of cometary behavior, but our assumptions about the nature of intelligence and technology on cosmic scales. The Loeb hypothesis would soon be put to its ultimate test as 3I Atlas reached the most active phase of its passage through the inner solar system. October 29, 2025, Perihelion Day. The moment when 3I Atlas would reach its closest approach to the Sun and, according to every model of cometary behavior, achieve maximum activity. Observatories worldwide had been preparing for this date since the object's discovery, expecting to witness the spectacular climax of an already extraordinary visitor. What they observed instead challenged the fundamental principles of cometary physics. As 3I Atlas approached within 0.65 astronomical units of the Sun, roughly two-thirds the distance from Earth to our local star, solar heating should have driven sublimation rates to their peak. The object should have blazed with activity, producing vast quantities of gas and dust as surface ices responded to increasing thermal energy. Instead, the observations revealed something unprecedented, a plateau effect. The Hubble Space Telescope's photometric measurements showed that 3I Atlas reached maximum brightness, not at perihelion, but approximately 2 weeks earlier, around October 15th. After that date, despite continuing solar approach and increasing thermal energy input, the object's activity level stabilized rather than continuing to increase. Dr. Matthew Knight from the U.S. Naval Academy, who had developed the standard models for predicting cometary brightness variations, found the plateau effect completely contrary to established heliocentric behavior. Every comet observed over decades of study had shown peak activity at or very near perihelion passage. The thermal physics was straightforward. More solar heating meant more sublimation and higher activity levels. 3I Atlas was rewriting those rules. The James Webb Space Telescope's infrared spectroscopy revealed why the plateau effect was so puzzling. The carbon dioxide production that had dominated the object's chemical signature wasn't simply leveling off. It was being supplemented by new chemical species that hadn't been detectable during the approach phase. Complex organic molecules began appearing in Webb's spectra around October 20th. Compounds like methanol, formaldehyde, and hydrogen, cyanide, materials that required different thermal conditions and surface compositions than the CO2-dominated chemistry observed earlier. It was as if 3I Atlas was revealing hidden layers of composition as it reached peak solar heating. But here's what made the chemical evolution particularly mysterious. The new compounds weren't simply replacing the carbon dioxide. Instead, they were being produced simultaneously, suggesting either multiple active regions with different compositions or some process that could generate diverse chemical species from a common source. The European Southern Observatory's SPHERE instrument detected structural changes in the coma that corresponded to the chemical evolution. New jet features appeared, emanating from regions of the nucleus that had been inactive during the approach phase. The jets showed different spectroscopic signatures, with some producing primarily CO2, while others generated the newly detected organic compounds. This selective activation pattern suggested that 3I Atlas possessed a heterogeneous surface composition, different regions with different volatile contents that became active at different temperatures. But the pattern was too organized, too systematic to be explained by random distribution of materials across the nucleus. The Atacama Large Millimeter Array's radio observations revealed that the electromagnetic phenomena were evolving in parallel with the chemical changes. The synchrotron radiation patterns shifted, the magnetic field perturbations intensified, and new plasma wave frequencies appeared in the data. The electromagnetic environment around 3I Atlas was becoming more complex rather than simply more intense. Dr. Geraint Jones's team at University College London attempted to model the electromagnetic evolution using established plasma physics. Their simulations suggested that the changing chemical composition was affecting the ionization environment around the nucleus, creating feedback loops between gas production and electromagnetic field generation. But the models required plasma densities and magnetic field strengths that were orders of magnitude higher than anything observed around natural comets. The electromagnetic environment of 3I Atlas was more reminiscent of active moons like Io, which derive their electromagnetic activity from internal tidal heating and volcanic processes. 3I Atlas had no such internal energy sources, or shouldn't have had them. The plateau effect raised fundamental questions about energy balance. If solar heating was no longer driving increased activity, despite continuing temperature rise, where was the additional thermal energy going? Was it being absorbed by phase changes in the nucleus composition? Was it driving internal chemical processes that weren't producing observable outgassing? Or was it being converted to electromagnetic energy through some unknown mechanism? The Transiting Exoplanet Survey satellite's continuous photometric monitoring detected another anomaly during the perihelion period, micro-variations in brightness that occurred on timescales of minutes to hours. These rapid fluctuations suggested either structural instability or some form of controlled variability that responded to local conditions. The variations weren't random. Test data revealed patterns, repeating cycles and correlated changes that implied systematic rather than chaotic processes. If 3I Atlas was experiencing structural breakdown, it was doing so in remarkably organized fashion. Radio telescopes worldwide coordinated to monitor the electromagnetic activity during perihelion passage. The Very Large Array, the European VLBI network, and the Atacama Large Millimeter Array combined their observations to create the highest resolution electromagnetic maps ever attempted for a cometary object. The results were unprecedented. The radio data revealed that 3I Atlas was generating coherent electromagnetic emissions, radio signals with structured frequencies and temporal patterns that suggested active generation rather than passive plasma processes. The signals weren't random noise from chaotic electromagnetic environments, but showed organization that implied underlying control mechanisms. As November approached and solar conjunction loomed, the peak activity paradox remained unresolved. 3I Atlas had demonstrated that our understanding of cometary behavior was incomplete in fundamental ways. The object had reached maximum activity before perihelion, revealed complex chemical evolution, generated extraordinary electromagnetic phenomena and produced structured signals that challenged the boundary between natural and artificial processes. The plateau effect meant that when 3I Atlas disappeared behind the Sun in late November, it would be at near maximum activity rather than ramping up toward a climax. When it emerged from conjunction in February 2026, observers would need to determine whether the object had maintained its activity level, evolved further, or returned to more conventional cometary behavior. The peak activity paradox had transformed 3I Atlas from an unusual interstellar visitor into something that defied categorization entirely. As 3I Atlas maintained its plateau of activity through early November, radio astronomers worldwide made a discovery that would fundamentally change how we thought about this interstellar visitor. Hidden within the electromagnetic noise of the object's plasma environment were patterns, structured emissions that occurred at specific frequencies and repeated with mathematical precision. The discovery came from Dr. Jill Tarter's team at the SETI Institute, who had been monitoring 3I Atlas as part of their ongoing search for technosignatures in astronomical data. While the primary focus of their observations was the electromagnetic environment around the object, their analysis revealed something unexpected: coherent radio transmissions embedded within the natural plasma emissions. The signals weren't constant. They appeared in bursts lasting several minutes, separated by periods of silence that ranged from hours to days. During active periods, the transmissions showed complex frequency modulation and timing patterns that were inconsistent with any known natural radio source. To understand why this discovery was so significant, consider what natural radio emissions from comets typically look like. Plasma interactions, synchrotron radiation, and electromagnetic turbulence all produce radio signals, but these are characterized by broadband noise, random frequency variations, and chaotic timing. The signals from 3I Atlas showed narrow band emissions, structured frequency patterns, and precise timing that suggested intentional generation. The Allen Telescope Array in California, designed specifically for SETI research, confirmed the discovery with independent observations. The ATA's sensitive receivers detected the same structured signals, ruling out instrumental artifacts or terrestrial interference. Multiple telescopes were detecting coherent transmissions from an object that was supposed to be a simple chunk of ice and rock from another star system. Dr. Dan Wertheimer from UC Berkeley's SETI-A-Home project analyzed the signal characteristics using the same techniques developed for searching for artificial transmissions from distant civilizations. The 3I Atlas signals showed several features consistent with artificial generation: narrow bandwidth, frequency stability, temporal coordination, and modulation patterns that contained apparent information content. But here's what made the signals particularly intriguing. They weren't random or chaotic. The frequency patterns showed mathematical relationships, harmonic progressions, geometric sequences, and numerical patterns that suggested structured information rather than natural electromagnetic phenomena. The Very Large Array's interferometric capabilities allowed astronomers to pinpoint the exact source of the transmissions within the 3I Atlas system. The signals weren't coming from the coma or the surrounding plasma environment. They were originating from the immediate vicinity of the nucleus itself, from a region smaller than the resolution limit of optical telescopes. This localization was crucial for understanding the signal generation mechanism. Natural radio emissions from comets typically originate from extended regions where plasma interactions occur throughout the coma. Coherent transmissions from a point source within the nucleus suggested either highly concentrated natural processes or some form of active signal generation. The European Space Agency's Deep Space Network stations at Kourou, Madrid, and Perth joined the global monitoring effort, using their sensitive receivers to track the 3I Atlas signals with unprecedented precision. The coordinated observations revealed that the transmissions were directional, stronger when observed from certain angles and weaker from others. This directional effect implied that the signal source wasn't radiating equally in all directions, but was instead focused or beamed toward specific regions of space. Natural radio sources typically show omnidirectional emission patterns, while directed transmissions suggest either physical structures that focus the radio waves or intentional targeting of specific directions. Dr. Seth Shostak from the SETI Institute emphasized the importance of systematic analysis before drawing conclusions about the signal's origin. While the characteristics we're observing are unusual for natural radio sources, he stated, we must exhaust all conventional explanations before considering unconventional ones. The signal analysis revealed additional complexity as November progressed. The transmission patterns weren't static, they evolved over time, showing changes in frequency, timing, and modulation that correlated with the object's approach to solar conjunction. It was as if 3i Atlas was responding to changing conditions by modifying its signal characteristics. The Breakthrough Listen project, which had been monitoring Oumuamua and 2i Borisov for potential techno-signatures, redirected their observational resources to focus entirely on 3i Atlas. Their analysis confirmed the structured nature of the transmissions and identified additional signal components that had been missed by previous observations. But the most intriguing aspect of the signals was what appeared to be intentional timing. The transmission bursts occurred at moments that seemed coordinated with astronomical events, orbital positions, solar activity levels, and even the observational schedules of major radio telescopes. The correlation was too strong to be coincidental, suggesting that whatever was generating the signals was aware of and responding to local astronomical conditions. The possibility that 3i Atlas was generating intentional radio transmissions forced astronomers to confront questions that ventured far beyond traditional cometary science. If the signals were artificial, what was their purpose? Were they attempts at communication, navigation beacons, or simply operational transmissions from some kind of technological system? The content analysis of the signals revealed patterns that resembled mathematical concepts, prime numbers, geometric progressions, and physical constants expressed in binary form. The information appeared to be structured as a sequence of increasingly complex mathematical relationships, similar to theoretical frameworks developed for interstellar communication protocols. But the signals also contained components that defied interpretation. Long sequences of apparently random data were interspersed with the mathematical patterns, creating an overall structure that seemed partly comprehensible and partly cryptic. It was as if 3i Atlas was transmitting both universal mathematical concepts and information specific to its own system or origin. As solar conjunction approached and the opportunity for continued observation diminished, the radio monitoring became increasingly urgent. The signals might provide crucial clues about the nature and origin of 3i Atlas, but they would become undetectable once the object disappeared behind the sun's radio interference. The silence between signals was becoming as significant as the transmissions themselves, suggesting that whatever was generating these patterns was operating according to a complex schedule that responded to multiple variables. The question was whether that schedule was driven by natural processes or represented something far more extraordinary. As the structured radio signals from 3i Atlas continued through mid-November, Dr. Avi Loeb proposed what would become known as the mirror navigation theory, a hypothesis that attempted to explain not just the signals themselves, but the entire constellation of anomalous behaviors exhibited by this interstellar visitor. The theory emerged from Loeb's analysis of the directional characteristics of the radio transmissions. The signals weren't broadcasting randomly into space. They showed preferential directions that correlated with the positions of nearby stellar systems. When mapped against the local galactic neighborhood, the transmission patterns seemed to be targeting specific star systems within a radius of approximately 50 light-years from our Sun. Consider the possibility, Loeb proposed in a paper submitted to the astrophysical journal Letters, that 3i Atlas represents a form of technological archaeology, a probe designed to study and report on stellar systems it encounters during its journey through the galaxy. The mirror navigation theory suggested that 3i Atlas wasn't simply a passive visitor from interstellar space, but an active exploration system that had been designed to gather and transmit information about the stellar systems it encountered. The radio signals weren't random emissions or attempts at communication with Earth. They were data transmissions directed toward distant receivers. Loeb's analysis of the signal timing patterns revealed what appeared to be systematic data collection and transmission cycles. The object would remain silent while gathering observational data about our solar system, then transmit burst communications containing that information toward specific stellar targets. The cycle would repeat with variations that suggested adaptive behavior based on the information being collected. The electromagnetic environment around 3I Atlas suddenly made sense within this framework. The magnetic field perturbations, synchrotron radiation, and plasma wave emissions weren't anomalous cometary behavior. They were the operational signatures of active technological systems. The extraordinary CO2 production wasn't driven by simple sublimation, but by reaction mass systems designed to provide propulsive control during the exploration mission. But the mirror navigation theory went beyond explaining the radio signals and electromagnetic anomalies. It provided a framework for understanding the entire sequence of apparently coincidental events that had characterized the 3I Atlas encounter. The trajectory geometry that seemed optimized for Earth-based observation wasn't accidental, it was intentional. An exploration probe would be designed to maximize its ability to study target systems, which would naturally optimize observational opportunities for any inhabitants of those systems. The timing of perihelion passage and solar conjunction wasn't cosmic irony. It was operational planning that balanced data collection requirements with communication windows. The chemical evolution from CO2-dominated to complex organic signatures wasn't random sublimation. It was systematic analysis of our solar system's chemistry, with different phases of the mission designed to test for different categories of compounds and processes. Dr. Jason Wright from Penn State University, who had established the theoretical framework for detecting technosignatures from distant civilizations, found Loeb's mirror navigation theory provocative but testable. The hypothesis made specific predictions about what should be observed if 3I Atlas was indeed an exploration probe rather than a natural object. First, the radio transmissions should show evidence of data compression and error correction, characteristics that would distinguish information transfer from natural electromagnetic phenomena. Second, the object's activity should respond to our solar system's characteristics in ways that suggested systematic investigation rather than random thermal processes. Third, the trajectory should show evidence of minor course corrections that couldn't be explained by gravitational forces alone. The signal analysis teams at the SETI Institute and Breakthrough Listen began searching for evidence of information encoding within the 3I Atlas transmissions. Advanced pattern recognition algorithms developed for analyzing potential artificial signals from distant stars were applied to the radio data from this nearby visitor. The results were intriguing. The transmissions did show characteristics consistent with compressed data transmission, redundancy patterns, error correction codes, and information density that exceeded what would be expected from natural radio sources. The mathematical content wasn't simply abstract number sequences, but appeared to contain specific information about physical measurements and astronomical observations. The European Space Agency's trajectory analysis team conducted detailed modeling to determine whether 3I Atlas showed any evidence of controlled navigation. Their calculations revealed subtle deviations from purely gravitational motion, minor course corrections that were consistent with low-thrust propulsion systems operating over extended periods. These trajectory corrections were small enough to be explained by non-gravitational forces like outgassing, but they were also systematic enough to suggest intentional guidance. The corrections appeared to optimize the object's path through our solar system for maximum scientific return, adjusting the trajectory to ensure optimal observational geometry for studying Earth, Mars, and the asteroid belt. But the mirror navigation theory also raised profound questions about the implications of such a discovery. If 3I Atlas was indeed an exploration probe, it suggested that interstellar exploration was not only possible, but was actively occurring. Somewhere within 50 light-years of our solar system, a civilization had developed the technology to launch systematic exploration missions across interstellar distances. Our solar system was being studied by intelligence that had achieved capabilities that remained beyond human reach. The theory also implied that 3I Atlas might not be unique. If one civilization had developed interstellar exploration capabilities, others might have done so as well. The galaxy could contain a network of exploration probes, studying stellar systems and reporting back to their creators across distances and timescales that dwarfed human experience. Dr. Sara Seager from MIT, while remaining cautious about the technological interpretation, acknowledged that if the mirror navigation theory is correct, it would represent one of the most significant discoveries in human history, proof that intelligence has achieved interstellar exploration capabilities. The theory also provided a disturbing explanation for the timing of 3I Atlas's arrival. If the object was designed to study our solar system, its arrival during the peak of human technological development wasn't coincidental. An advanced civilization might have been monitoring our system for centuries or millennia, waiting for clear evidence of emerging intelligence before dispatching detailed exploration missions. As solar conjunction approached and the opportunity for continued observation diminished, the mirror navigation theory remained speculative but compelling. Whether 3I Atlas was a natural object exhibiting unprecedented cometary behavior or an artificial probe conducting systematic exploration, it had forced humanity to confront the possibility that we were not alone in the galaxy and that we were being watched. When we speak of astronomical scales, we typically mean distances measured in light years, masses measured in solar units, and time periods measured in millions of years. But the true scale of the 3I Atlas encounter wasn't measured in these conventional units. It was measured in the gap between what we expected to understand and what we actually comprehended about our place in the cosmos. Consider the implications if 3I Atlas was indeed operating according to Loeb's mirror navigation theory. The object would represent technology that could travel between star systems, operate independently for millions of years, and conduct sophisticated scientific investigations of alien worlds. Such capabilities would indicate a level of technological advancement that exceeded human achievement by orders of magnitude. But the scale problem went deeper than technological capability. It touched the fundamental question of cosmic loneliness. For the entire history of human civilization, we have been alone with our intelligence in an apparently empty universe. The search for extraterrestrial intelligence has been searching for over 60 years without detecting clear evidence of other technological civilizations. The Fermi paradox has haunted our understanding of galactic evolution, asking why a universe that should be teeming with intelligence appears so silent. 3I Atlas was potentially providing an answer to that paradox, and the answer was terrifying in its implications. If the object was artificial, it suggested that advanced civilizations didn't announce their presence with powerful radio beacons or obvious megastructures. Instead, they conducted subtle, sophisticated investigations that could easily be mistaken for natural phenomena. The galaxy might be full of intelligence that remained invisible because it was actively avoiding detection. The radio signals from 3I Atlas weren't directed toward Earth. They were pointing toward distant star systems, suggesting communication networks that operated across scales of space and time that dwarfed human experience. An exploration probe visiting our solar system wouldn't be an isolated mission, but part of a systematic exploration program that might encompass hundreds or thousands of stellar systems. Dr. Frank Drake, who had developed the famous equation for estimating the number of communicating civilizations in our galaxy, found the 3I Atlas observations deeply troubling from a statistical perspective. If even one civilization had achieved interstellar exploration capabilities, the galaxy should contain evidence of widespread technological activity across millions of years of development. The absence of such evidence implied either that intelligence was extraordinarily rare in the universe, or that advanced civilizations operated according to principles that made them nearly invisible to developing species like humanity. 3I Atlas might represent our first glimpse of this hidden galactic community, but the scale implications extended beyond the mere existence of other intelligence. The systematic nature of the 3I Atlas mission suggested that our solar system had been under observation for extended periods. An exploration probe wouldn't arrive by accident during the brief period of human technological development. It would arrive because its creators had been monitoring our system and had detected evidence of emerging intelligence. This raised the possibility that humanity's development was being studied, catalogued, and reported to intelligence networks that spanned the galaxy. Our technological progress, our exploration of space, our attempts to detect extraterrestrial intelligence, all of this might be known to civilizations that had been observing us for centuries or millennia. The timing of 3I Atlas's arrival, just as human space-based astronomy reached unprecedented capabilities, suggested either remarkable coincidence or deliberate planning. An advanced civilization might have calculated exactly when we would develop the technological sophistication necessary to detect and study an interstellar probe, timing their mission to maximize both information gathering and the possibility of contact. Dr. Michio Kaku from City College of New York described the potential implications as representing a phase transition in human understanding. If 3I Atlas was artificial, it would mark the end of human cosmic isolation and the beginning of an era where we understood ourselves as part of a galaxy-spanning community of intelligence. But this transition would also force humanity to confront our position within that community. A civilization capable of interstellar exploration would possess capabilities that exceeded our own by factors that might be difficult to comprehend. The technological gap between such a civilization and humanity would be comparable to the gap between human technology and the simplest biological life forms. This scale differential raised profound questions about the intentions and motivations of any intelligence behind 3I Atlas. Advanced civilizations might operate according to ethical frameworks, strategic considerations, and long-term goals that were completely alien to human experience. Their interest in our solar system might be scientific, exploitative, protective, or something entirely beyond our conceptual frameworks. The electromagnetic signals from 3I Atlas contained information that could potentially transform human understanding of physics, technology, and the nature of intelligence itself. But accessing that information would require capabilities that we didn't possess. We were in the position of early humans trying to understand quantum mechanics, aware that profound knowledge existed, but lacking the conceptual tools to comprehend it. The scale of the 3I Atlas encounter wasn't measured in kilometers or years, but in the expansion of human awareness from a species alone in the universe to a species under observation by intelligence that operated on cosmic scales. Whether that awareness brought hope or terror would depend on what we discovered about the intentions of those who might be watching us. As solar conjunction approached and 3I Atlas prepared to disappear behind the sun, humanity faced the possibility that when the object emerged from conjunction, it might bring answers to questions we had been afraid to ask about our place in the cosmos. As November progressed and solar conjunction loomed, the structured radio signals from 3I Atlas presented humanity with an unprecedented challenge. How do you respond to potential communication from an intelligence that operates on interstellar scales? The signals themselves weren't directed toward Earth. They were being transmitted toward distant star systems in what appeared to be systematic data reporting. But embedded within the transmission patterns were mathematical concepts and physical constants that suggested the possibility of intentional communication with any intelligence capable of detecting and interpreting the signals. Dr. Douglas Vakosh from METI International, who had spent decades developing protocols for messaging extraterrestrial intelligence, found the 3I Atlas signals uniquely challenging from a communication theory perspective. Unlike traditional SETI scenarios, where signals would be detected from distant star systems with years available for analysis and response planning, 3I Atlas was present in our solar system for a limited time with a rapidly closing window for any potential interaction. The communication dilemma wasn't simply technical, it was philosophical and political. If 3i Atlas was indeed artificial, any response from humanity would represent our first communication with intelligence from another star system. The content, timing, and method of such communication would have implications that extended far beyond scientific discovery. The international committee that had been established to coordinate 3i Atlas observations expanded its mandate to address potential communication protocols. Representatives from space agencies, scientific institutions, and government organizations worldwide struggled with questions that had never been faced in human history. Who speaks for Earth? What messages should be sent? What risks might communication entail? Dr. John Billingham, who had chaired NASA's early SETI committees, emphasized the unprecedented nature of the situation. All of our protocols for extraterrestrial contact assumed detection of signals from distant civilizations with years or decades available for analysis and international consultation. 3i Atlas has compressed that timeline to weeks, forcing decisions that should have taken years of careful deliberation. The mathematical content of the 3i Atlas signals provided a potential framework for response. The transmissions contained prime number sequences, geometric progressions, and physical constants expressed in binary notation, universal mathematical concepts that could serve as a foundation for more complex communication. The Arecibo message, transmitted toward the globular cluster M13 in 1974, had established precedent for mathematical communication protocols. The 3i Atlas signals showed similar mathematical structures, but with far greater complexity and apparent information content. Responding with comparable mathematical concepts might demonstrate human understanding and technological capability. But the response dilemma extended beyond mathematical communication. The signals from 3i Atlas suggested systematic data collection about our solar system, including Earth's characteristics and potentially humanity's technological signatures. Any response would provide additional information about human capabilities and intentions, information that might be valuable to intelligence with unknown motivations. The European Space Agency's Deep Space Network possessed the transmission capabilities necessary to send focused radio signals toward 3i Atlas, but such transmissions would be detected by radio telescopes worldwide and would announce humanity's attempt at extraterrestrial communication to every intelligence-gathering organization on Earth. Dr. Seth Shostak from the SETI Institute argued for caution in any communication attempts. We're dealing with intelligence that has demonstrated technological capabilities far exceeding our own. Any communication from humanity should be carefully considered for its potential, implications, and consequences. The communication protocols developed by METI International suggested starting with simple mathematical acknowledgements, prime numbers, geometric sequences, and physical constants that would demonstrate understanding of the signal content without revealing detailed information about human technology or society. But the timing constraints of solar conjunction created pressure for immediate action. Once 3i Atlas disappeared behind the Sun in late November, direct communication would become impossible until the object emerged from conjunction in February 2026. By that time, the object would be racing away from the inner solar system with potentially reduced activity levels and weaker signal strength. The Chinese Academy of Sciences proposed using their 500-meter aperture spherical telescope, FAST, to attempt communication during the final days before conjunction. FAST's enormous collecting area and precise pointing capabilities made it ideal for transmitting focused signals toward 3i Atlas at maximum power levels. The proposal created immediate international controversy. Unilateral communication attempts by any single nation raised concerns about representation, coordination, and potential consequences for all of humanity. If 3i Atlas was monitoring human activities, uncoordinated communication attempts might send unintended messages about human political organization and decision-making processes. The United Nations Office for Outer Space Affairs convened emergency sessions to address the communication protocols, but reaching international consensus on response strategies proved impossible within the available time frame. Different nations had different perspectives on the risks and benefits of communication, different technological capabilities for transmission, and different political motivations for participating in potential contact. Meanwhile, the signals from 3I Atlas continued their systematic pattern of data, transmission toward distant star systems. Analysis of the signal content revealed increasing complexity as the object approached conjunction, with new mathematical concepts and physical measurements being added to the transmission sequences. The evolving signal content suggested that 3I Atlas was conducting real-time analysis of our solar system and incorporating new discoveries into its data transmissions. The object appeared to be learning about our local environment and reporting that information to unknown recipients in other star systems. Dr. Jill Tarter's team at the SETI Institute detected what appeared to be specific references to Earth's characteristics in the later signal transmissions. Sequences that correlated with Earth's orbital parameters, atmospheric composition, and electromagnetic signatures suggested that 3I Atlas was specifically studying our planet and including that information in its communications. This focused attention on Earth raised both exciting possibilities and troubling concerns. If 3I Atlas was reporting detailed information about Earth to intelligence in other star systems, it might be announcing the presence of a life-bearing world with emerging technological civilization. Such announcements could attract future missions, scientific expeditions, or other forms of contact, but they could also attract attention that might not be benevolent. Advanced civilizations might view developing worlds as resources, threats, or simply interesting specimens for study. Earth's location, characteristics, and technological level would become known to intelligence networks that operated on galactic scales with motivations and ethical frameworks that remained completely unknown. The communication dilemma ultimately remained unresolved as 3I Atlas approached solar conjunction. International disagreements about response protocols, concerns about unintended consequences, and simple lack of time prevented coordinated communication. Attempts during the optimal window. As the object disappeared behind the Sun's interference in late November 2025, humanity was left with the knowledge that we had possibly encountered intelligence from another star system, but had failed to take advantage of a unique opportunity for communication. The signals faded into solar radio noise, leaving behind only recorded data and the profound knowledge that we might no longer be alone in the universe. The question now was what would emerge from conjunction, and whether humanity would be better prepared for communication when 3I Atlas returned to observable space in February 2026. As 3I Atlas disappeared behind the Sun's glare in late November 2025, the scientific community faced a crucial period of analysis and prediction. The observations collected during the approach phase had generated multiple competing hypotheses about the object's nature, but the upcoming emergence from solar conjunction would provide the ultimate test of these theories. The natural comet hypothesis, while severely challenged by the electromagnetic anomalies and structured radio signals, made specific predictions about what should be observed when 3I Atlas emerged from conjunction. If the object was a conventional interstellar comet, exhibiting unusual but ultimately explainable behavior, it should show decreased activity as it moved away from the Sun, conventional outgassing chemistry as exotic volatiles were depleted, and the cessation of electromagnetic phenomena as the plasma environment returned to normal levels. Dr. Matthew Knight's team at the Naval Academy developed detailed models for natural comet evolution that could be tested against post-conjunction observations. Their predictions suggested that 3I Atlas should be significantly less active when it emerged in February 2026, with CO2 production reduced by at least an order of magnitude and the complex organic chemistry reverting to simpler compounds. The fragmentation hypothesis made different predictions. If 3I Atlas had been breaking apart during its approach to perihelion, the conjunction period might have accelerated structural breakdown due to increased thermal stress. The object that emerged should show evidence of multiple separate components, debris trails, or complete structural collapse. Dr. David Jewett's fragmentation models predicted that a braking comet should show expanding clouds of debris, multiple brightness peaks corresponding to separate fragments and evolving orbital parameters, as the pieces separated under their own gravitational influence. Long exposure imaging should reveal linear features or debris trains that would be diagnostic of recent fragmentation events. The mirror navigation theory made the most specific and testable predictions. If 3I Atlas was indeed an artificial exploration probe, its behavior during and after conjunction should show evidence of controlled activity rather than simple thermal response to solar heating. Avi Loeb's team predicted that an artificial object should maintain electromagnetic activity levels during conjunction, show evidence of course corrections or controlled orientation changes, and potentially alter its signal transmission patterns based on information gathered during the close solar approach. The radio emissions should remain coherent and structured rather than degrading into natural plasma noise. The key observational tests were identified by the International Coordination Committee as requiring immediate attention when 3I Atlas emerged from conjunction. Electromagnetic activity monitoring would determine whether the magnetic field perturbations, synchrotron radiation, and plasma wave emissions continued at artificial levels or returned to background. Natural objects should show rapid decline in electromagnetic phenomena as solar heating decreased, while artificial systems might maintain activity independent of solar distance. Radio signal analysis would search for continuation of the structured transmissions detected during the approach phase. Natural radio sources should become undetectable as the object moved away from the sun, while artificial transmitters might continue operating or even increase activity as communication windows with distant receivers improved. Chemical composition tracking would monitor whether the exotic 8:1 CO2 to water ratio persisted or evolved toward more conventional cometary chemistry. Natural sublimation should deplete the most volatile components first, gradually changing the chemical ratios as different ices were exhausted. Structural integrity assessment would determine whether 3I Atlas maintained coherent morphology or showed evidence of fragmentation, debris production, or other structural changes. High-resolution imaging would be crucial for detecting any physical evolution of the nucleus or coma structure. Trajectory analysis would search for evidence of non-gravitational forces that couldn't be explained by conventional outgassing. Artificial objects might show controlled trajectory corrections, while natural objects should follow predictable orbital mechanics modified only by reaction forces from gas production. The James Webb Space Telescope was positioned to provide the most critical tests when 3I Atlas emerged from conjunction. Webb's infrared capabilities could detect thermal emission from the nucleus independent of reflected sunlight, potentially revealing internal heat sources that would distinguish artificial from natural objects. Webb's spectroscopic sensitivity could also detect trace compounds that might indicate artificial materials or processes. Isotopic ratios inconsistent with natural formation, synthetic compounds not found in natural objects, or emission signatures from technological processes would provide definitive evidence for artificial origin. The Atacama Large Millimeter Array prepared coordinated observations to map any residual electromagnetic activity with unprecedented resolution. ALMA's interferometric capabilities could distinguish between natural plasma processes and artificial electromagnetic generation based on the spatial distribution and temporal evolution of radio emissions. Ground-based observatories worldwide developed observation protocols to ensure continuous monitoring during the emergence period. The object would be faint and potentially changed after its conjunction passage, requiring coordinated efforts to track its evolution and detect any unusual characteristics. But the most crucial test would be the simplest. Would 3I Atlas still be there when it emerged from behind the sun? Natural comets occasionally disintegrated completely during close solar passages, destroyed by thermal stress or structural instability. If 3I Atlas was a natural object, pushed beyond its structural limits by unusual composition or fragmentation, it might not survive conjunction at all. Artificial objects however, should be designed to survive such encounters. The disappearance of 3I Atlas during conjunction would actually support the natural hypothesis by suggesting that the object had been destroyed by processes that advanced technology should have been able to withstand. The emergence from conjunction would provide what philosophers of science call a crucial experiment, an observation that could definitively distinguish between competing hypotheses. The stakes couldn't have been higher. The results would either confirm 3I Atlas as an unusual but natural interstellar comet, or provide evidence for the first confirmed artificial object from another star system. As February 2026 approached, telescopes worldwide prepared for observations that might mark either the resolution of an astronomical puzzle or the beginning of a new era in human understanding of our place in the cosmos. February 12, 2026. After 73 days of solar conjunction, 3I Atlas was scheduled to emerge from behind the sun's glare and become observable again to Earth-based telescopes. Observatories worldwide had been counting down to this moment, preparing for observations that would determine whether humanity had encountered the first confirmed artificial object from another star system. The initial detection came from the Solar and Heliospheric Observatory, SOHO, whose coronagraph instruments could observe objects close to the Sun by blocking the star's direct light. At 1423 UTC, SOHO detected a point source of light at the predicted position of 3I Atlas, confirming that the object had survived its passage behind the Sun. But something was wrong with the brightness. Dr. Carl Battams from the Naval Research Laboratory, who coordinated SOHO's comet observations, immediately recognized that 3I Atlas was significantly brighter than predicted models suggested. If the object was a natural comet moving away from the Sun, it should have been fading as solar heating decreased and volatile. Sublimation slowed. Instead, it appeared to be maintaining or even increasing its activity level. Within hours, ground-based observatories began confirming the unexpected brightness. The Atacama Large Millimeter Array detected strong radio emissions at the same frequencies that had characterized 3I Atlas before conjunction. Not only had the electromagnetic activity survived the solar passage, it had intensified. The James Webb Space Telescope, positioned at the L2 Lagrange point with optimal viewing geometry, provided the first detailed spectroscopic analysis of the emerged object. Webb's infrared observations revealed that the chemical composition had evolved during the conjunction period, but not in the direction predicted by natural comet models. Instead of showing depletion of volatile compounds and simplification of chemistry, 3I Atlas was producing new spectral signatures that hadn't been detected during the approach phase. Complex organic molecules that required specific synthesis conditions were appearing in the coma, suggesting either internal chemical processes or the activation of previously dormant systems. Dr. Stephanie Millam's team at NASA Goddard, responsible for Webb's astrobiology observations, found the new chemical signatures completely inconsistent with natural cometary evolution. The compounds being detected required energy inputs and synthesis pathways that shouldn't exist in a simple ice and rock nucleus moving away from the Sun. The radio observations provided even more dramatic evidence of unusual activity. The Very Large Array detected not only the continuation of structured transmissions, but the appearance of new signal patterns that hadn't been present before conjunction. The transmissions were stronger, more complex, and appeared to be directed toward different stellar targets than the pre-conjunction signals. Dr. Jill Tarter's team at the SETI Institute analyzed the evolved signal patterns and found evidence of information encoding that exceeded the complexity of the earlier transmissions. The post-conjunction signals contained mathematical concepts, physical constants, and apparently structured data that suggested systematic information transfer rather than natural electromagnetic phenomena. But the most significant discovery came from high-resolution imaging by the Hubble Space Telescope. When Hubble's cameras achieved their first clear view of 3I Atlas after conjunction, they revealed structural changes that defied explanation through natural processes. The coma morphology had evolved from the relatively symmetrical gas cloud observed before conjunction to a structured pattern with distinct geometric features. The gas distribution showed organized flows, apparent boundaries, and what could only be described as architectural elements that suggested active control rather than passive sublimation. The nucleus itself, while still unresolved at Hubble's maximum magnification, showed brightness variations that implied either rapid rotation, surface changes, or active modification of its reflective properties. The photometric data suggested that something on or within the nucleus was responding to post-conjunction conditions in ways that natural objects shouldn't. Dr. Alan Fitzsimmons from Queen's University Belfast, who had led the observational campaign for both Oumuamua and 2I Borisov, described the post-conjunction observations as unlike anything in the catalogue of cometary behavior. The object that emerged from behind the Sun was more active, more complex, and more structured than the one that had entered conjunction. The trajectory analysis provided additional evidence for non-natural behavior. Instead of following the predicted orbital path based on gravitational forces and pre-conjunction outgassing, 3I Atlas showed minor but systematic deviations that suggested controlled course corrections. The European Space Agency's trajectory modeling team, led by Dr. Marco Micheli, calculated that the observed path changes required propulsive forces that exceeded any reasonable estimates for natural outgassing. The trajectory modifications appeared to be optimizing the object's path for extended observation from Earth, adjusting its orbit to maintain favorable viewing geometry. This controlled navigation provided the strongest evidence yet for artificial origin. Natural objects couldn't modify their trajectories with such precision, and the apparent optimization for Earth-based observation suggested awareness of and response to human observational capabilities. The electromagnetic environment around 3I Atlas had also evolved during conjunction. The magnetic field perturbations detected by space-based magnetometers were stronger and more organized than before solar passage. The synchrotron radiation showed structured patterns that implied active generation rather than passive plasma processes. Radio telescopes worldwide detected what appeared to be active communication between 3I Atlas and distant stellar targets. The signal patterns showed temporal coordination that suggested real-time information exchange across interstellar distances, a capability that would require technology far exceeding human achievements. As February progressed and post-conjunction observations accumulated, the evidence for artificial origin became increasingly difficult to dismiss. The enhanced activity, evolved chemistry, structured emissions, controlled navigation, and organized electromagnetic phenomena all pointed toward technology rather than natural processes. But the implications of confirming artificial origin were profound and troubling. If 3I Atlas was indeed an exploration probe from another civilization, its enhanced activity after conjunction suggested that it had completed its primary mission objectives and was now operating according to different parameters. The increased radio transmissions toward distant star systems implied that detailed information about our solar system, Earth's characteristics and human technological capabilities was being reported to unknown recipients across interstellar distances. Humanity's existence and level of development were potentially becoming known to intelligence networks that operated on galactic scales. The emergence from conjunction had transformed 3I Atlas from an intriguing astronomical puzzle into what might be the most significant discovery in human history. Proof that intelligence had achieved interstellar exploration capabilities and that Earth was under systematic observation by advanced civilizations. The question now was not what 3I Atlas was, but what its presence in our solar system meant for humanity's future. 3 weeks after emerging from solar conjunction, 3I Atlas began exhibiting behavior that eliminated any remaining possibility of natural origin. The object was accelerating. Not the gentle, predictable acceleration of outgassing that characterized normal comets, but systematic controlled acceleration that was modifying its trajectory in ways that defied every principle of celestial mechanics for natural objects. The acceleration was small but persistent, measurable only through precise astrometric observations, but its implications were staggering. Dr. Marco Micheli's trajectory analysis team at the European Space Agency detected the anomaly through careful comparison of 3I Atlas's predicted position with its observed location. The object was arriving at specific points in its orbit several minutes earlier than gravitational models predicted, indicating additional forces beyond solar gravity and radiation pressure. The acceleration wasn't random or chaotic like the outgassing effects observed in natural comets. Instead, it showed systematic patterns that suggested intentional control. The object was accelerating in directions that optimized its trajectory for extended observation from Earth while maintaining favorable communication geometry with specific stellar targets. What we're observing, Micheli reported to the International Astronomical Union's Emergency Committee, is controlled propulsion that exceeds the capabilities of any known natural process. This is navigation, not physics. The magnitude of the acceleration was approximately 10^7 meters per second squared. Tiny by terrestrial standards, but enormous for an object that should be governed purely by gravitational forces. To put this in perspective, the acceleration was comparable to the thrust-to-weight ratio of ion propulsion systems used on advanced spacecraft, but sustained over periods that exceeded the operational lifetime of any human technology. The direction of acceleration provided additional evidence for artificial control. Natural outgassing typically creates forces that are either radial from the Sun or aligned with the object's rotation axis. The 3I Atlas acceleration was consistently oriented to modify the orbit in ways that maximized scientific return, maintaining optimal solar distance for continued activity while adjusting the trajectory for favorable Earth observation geometry. The James Webb Space Telescope's thermal imaging revealed possible mechanisms for the acceleration. Webb detected infrared emissions from specific regions of the nucleus that were consistent with directed energy release rather than uniform solar heating. The emission patterns suggested focused heating or propulsive systems operating at temperatures and intensities that natural sublimation couldn't explain. Dr. Pontus Brandt from Johns Hopkins Applied Physics Laboratory, who had designed propulsion systems for interplanetary missions, analyzed the thermal signatures and concluded that they were consistent with controlled energy release from internal systems rather than solar-driven surface processes. The acceleration created a practical problem for continued observation. If 3I Atlas was modifying its trajectory through artificial propulsion, predicting its future position would require understanding its navigation objectives rather than simply calculating gravitational orbital mechanics. The object was essentially writing its own flight plan in real time. Radio observations provided crucial insights into the navigation system. The Very Large Array detected bursts of coherent electromagnetic radiation that preceded trajectory changes by several hours. The radio transmissions appeared to be navigation commands, or status reports that correlated with subsequent propulsive maneuvers. The temporal correlation between radio signals and trajectory changes suggested that 3I Atlas was either receiving navigation instructions from external sources or reporting its navigation decisions to distant controllers. Either possibility implied real-time communication across interstellar distances, a capability that would revolutionize human understanding of physics and communication technology. Dr. Seth Shostak from the SETI Institute attempted to decode the navigation-related radio signals using cryptographic techniques developed for analyzing potential extraterrestrial communications. The signals showed mathematical structures and temporal patterns that suggested information content, but the encoding methods remained beyond human comprehension. We're observing information transfer that operates on principles we don't understand, Shostak reported. The signals contain apparent data structures and error correction codes, but the mathematical basis for the encoding exceeds our current theoretical frameworks. The acceleration anomaly also provided crucial evidence about the object's mass and structure. The observed acceleration, combined with estimates of the propulsive force based on thermal emissions, allowed calculations of the object's total mass that were inconsistent with previous estimates based on gravitational effects. 3I Atlas appeared to be either much less massive than its size suggested, implying hollow internal structure or exotic materials, or much more massive than gravitational observations indicated, suggesting some form of gravitational shielding or modification. Both possibilities pointed toward technology that operated on physical principles beyond human understanding. The acceleration patterns showed optimization characteristics that implied advanced artificial intelligence or autonomous navigation systems. The trajectory modifications weren't simply following pre-programmed instructions, but appeared to be responding to changing conditions and optimizing for multiple objectives simultaneously. The object was maintaining optimal solar distance for continued power generation, adjusting its path to maximize Earth observation opportunities, and positioning itself for favorable communication geometry with multiple stellar targets. This multi-objective optimization required computational capabilities and autonomous decision-making that exceeded any human technology. Ground-based radar observations attempted to map the internal structure of 3I Atlas to understand the physical basis for its propulsive capabilities. The Arecibo Observatory and the Green Bank Telescope coordinated radar mapping experiments that revealed density variations within the nucleus consistent with complex internal architecture. The radar data suggested that 3I Atlas contained both dense structural elements and void spaces that could house propulsion systems, power, generation equipment, or scientific instruments. The internal organization showed apparent design principles rather than the random structure expected from natural accretion processes. As March 2026 progressed and the acceleration continued, the astronomical community was forced to acknowledge that they were observing technology in operation. The systematic, controlled, optimized nature of the trajectory modifications eliminated natural explanations and confirmed artificial origin beyond reasonable doubt. But the confirmation of artificial origin raised immediate questions about intentions and capabilities. If 3I Atlas could modify its trajectory with such precision, it could potentially extend its mission duration indefinitely, maintaining position within our solar system for detailed study or departing at will toward any destination within the galaxy. The acceleration anomaly had transformed the 3I Atlas encounter from a temporary astronomical event into a permanent change in human cosmic circumstances. Advanced technology was operating within our solar system, and its controllers possessed capabilities that exceeded human achievement by margins that remained difficult to comprehend. By April 2026, as 3I Atlas continued its controlled navigation through the outer solar system, the global response to confirmed extraterrestrial technology had fragmented into competing approaches that reflected fundamentally different assessments of risk, opportunity, and human preparedness for contact with advanced civilizations. The scientific community, while unified in accepting the artificial origin of 3I Atlas, remained divided on appropriate response protocols. The unprecedented nature of the contact scenario, an active technological object within our solar system rather than distant radio signals, compressed decision timelines and eliminated the luxury of extended deliberation that previous SETI protocols had assumed. Dr. Jill Tarter's team at the SETI Institute advocated for immediate, systematic attempts at communication using the mathematical frameworks that 3I Atlas itself had demonstrated in its radio transmissions. Their approach emphasized building on the number theory and physical constants that the object had already transmitted, gradually developing more complex communication protocols that could establish meaningful information exchange. We have a unique opportunity, Tarter argued, before the hastily convened UN Committee on Peaceful Uses of Outer Space to engage with confirmed extraterrestrial technology under controlled conditions. The object is demonstrating peaceful intent through its non-threatening behavior and apparent scientific mission. Failing to attempt communication would be a historic missed opportunity. The communication advocates proposed using the Deep Space Network's most powerful transmitters to send mathematical acknowledgements toward 3I Atlas, beginning with prime number sequences and progressing to more complex mathematical concepts. The approach was based on established METI protocols, but adapted for the unique circumstances of an interstellar visitor operating within our solar system. However, a significant portion of the scientific community, led by Dr. Martin Rees from Cambridge University, urged extreme caution in any communication attempts. Rees argued that the technological capabilities demonstrated by 3I Atlas implied civilizational advancement that exceeded human development by potentially millions of years, creating fundamental asymmetries in any potential interaction. "We are in the position of ants observing a highway construction project," Rees warned. "We can observe the technology in operation, but we cannot comprehend the intentions, capabilities, or consequences of interaction with intelligence that operates on such scales." The caution advocates pointed to the acceleration anomaly and navigation capabilities as evidence of technology that could easily be applied to destructive purposes. If 3I Atlas could modify its trajectory with precision, it could potentially redirect asteroids, alter planetary orbits, or deploy weapons systems that operated on principles beyond human understanding. Government responses varied dramatically based on national security assessments, technological capabilities, and political considerations. The United States Department of Defense classified 3I Atlas observations under the highest security levels, while simultaneously coordinating with NASA to maintain continuous monitoring of the object's activities and trajectory. China's space program announced independent communication attempts using their 500-meter aperture spherical telescope, FAST, arguing that contact with extraterrestrial intelligence was too significant to be delayed by international bureaucratic processes. The Chinese Academy of Sciences began transmitting mathematical sequences toward 3I Atlas without coordinating with other national space agencies. The European Space Agency adopted a middle position, continuing systematic observation and analysis while developing communication protocols that could be implemented if international consensus emerged. ESA's approach emphasized building technological capabilities for potential communication while avoiding unilateral contact attempts that might compromise coordinated global responses. Russia's space agency, Roscosmos, focused on developing enhanced detection capabilities to monitor any additional interstellar visitors that might arrive in our solar system. Russian scientists argued that 3I Atlas was unlikely to be unique and that systematic surveys for additional artificial objects should take priority over communication attempts with a single visitor. The private space industry contributed both resources and complications to the response matrix. Companies with deep space communication capabilities offered their services for potential communication attempts while also developing independent observation programs that operated outside government oversight. SpaceX announced plans to launch specialized monitoring satellites that could track 3I Atlas with unprecedented resolution, while Blue Origin proposed developing rapid response spacecraft that could potentially intercept and study the object if it remained in the outer solar system long enough for human missions to reach it. Public reaction ranged from excitement and curiosity to fear and religious reinterpretation. Opinion polls showed that approximately 40% of the global population viewed the 3I Atlas encounter as a positive development that could advance human knowledge and technology, while 35% expressed concern about potential threats from advanced alien intelligence. Religious leaders struggled to incorporate confirmed extraterrestrial intelligence into theological frameworks that had been developed assuming human uniqueness in the universe. Some denominations embraced the discovery as evidence of divine creativity on cosmic scales, while others warned that deceptive spiritual forces might be using technological displays to undermine human faith. The economic implications of confirmed extraterrestrial technology created both opportunities and disruptions across multiple industries. Stock markets showed extreme volatility as investors attempted to assess which sectors might benefit from potential technology transfer and which might be obsoleted by access to advanced alien knowledge. Technology companies experienced dramatic valuation changes based on speculation about their potential to reverse engineer or interface with extraterrestrial systems. Aerospace and defense contractors saw increased government investment in monitoring and response capabilities, while communication companies developed new services for tracking and potentially communicating with interstellar visitors. Academic institutions worldwide restructured their research priorities to address the implications of confirmed alien intelligence. New interdisciplinary programs emerged, combining astronomy, anthropology, psychology, and political science to study the potential impacts of sustained contact with advanced civilizations. The decision matrix facing humanity was unprecedented in its complexity and consequences. Every choice, from communication attempts to preparation for additional visitors, carried implications that could affect the entire future trajectory of human civilization. As 3I Atlas continued its systematic navigation through our solar system, humanity was forced to confront the reality that we were no longer alone and that our decisions during this first confirmed contact would establish precedents for all future interactions with the galactic community we had just discovered. The window for coordinated global response was closing as the object's enhanced post-conjunction activity suggested that its mission objectives were evolving. Whether humanity would rise to meet this cosmic challenge with wisdom and unity, or fragment into competing responses that reflected our terrestrial divisions, remained to be determined. In May 2026, as international debates over communication protocols continued, 3I Atlas began transmitting something unprecedented: structured information packages that appeared to contain scientific knowledge far exceeding human understanding of physics, chemistry, and engineering. The transmissions weren't directed toward distant star systems like the earlier communication sequences. Instead, they were being broadcast on frequencies and at power levels specifically designed for optimal reception by Earth-based radio telescopes. For the first time since its arrival, 3I Atlas was deliberately communicating with humanity. Dr. Frank Drake's team at the SETI Institute was the first to recognize the significance of the new transmission patterns. Unlike the mathematical sequences and physical constants that had characterized the object's earlier signals, these new transmissions contained complex data structures that appeared to represent detailed scientific information. "What we're receiving," Drake reported to the International Coordination Committee, "appears to be systematic knowledge transfer. The object is teaching us." The information packages followed a pedagogical structure that suggested deliberate educational intent. Each transmission began with mathematical concepts that were accessible to human science, then progressed to increasingly sophisticated theoretical frameworks that extended beyond current human knowledge. The first packages contained advanced mathematical tools, number theory concepts, geometric relationships, and algebraic structures that human mathematicians could understand, but had not yet discovered. The mathematical content was elegant, powerful, and immediately applicable to problems in physics and engineering that had previously been intractable. Dr. Terence Tao, from UCLA, who led the mathematical analysis team, described the transmitted mathematics as simultaneously familiar and revolutionary. The concepts were based on principles that human mathematicians could verify and understand, but combined these principles in ways that opened entirely new theoretical possibilities. The mathematical packages were followed by physics concepts that challenged fundamental assumptions about space, time, energy, and matter. The transmissions included theoretical frameworks for faster-than-light communication, energy sources that operated by manipulating vacuum fluctuations, and gravitational control systems that could modify space-time geometry. Dr. Lisa Randall from Harvard analyzed the physics content and found it consistent with established principles, but extending them in directions that human theory had not explored. The transmitted physics wasn't contradicting known laws of nature, but was revealing additional layers of natural law that human science had not yet discovered. The engineering applications that followed the theoretical physics were even more remarkable. The transmissions included detailed specifications for technologies that could revolutionize human capabilities, propulsion systems that operated by manipulating gravitational fields, communication devices that could transmit information instantaneously across arbitrary distances, and energy generation systems that could tap directly into the quantum vacuum. But the Knowledge Transfer Protocol wasn't simply dumping advanced information indiscriminately. Instead, it was carefully structured to ensure that humanity could safely absorb and implement the new knowledge without causing technological disruption that might destroy human civilization. Each technology package included detailed safety protocols, implementation guidelines, and warnings about potential misuse or unintended consequences. The transmissions emphasized that the technologies were being shared for peaceful purposes and included explicit cautions about military applications that could pose existential risks. Dr. Nick Bostrom from Oxford University, who had studied existential risks from advanced technology, found the safety emphasis reassuring but also concerning. The detailed warnings suggested that the technology's creators understood the potential for advanced knowledge to destroy developing civilizations and were taking precautions to prevent such outcomes. The Knowledge Transfer Protocol also included information about the civilization that had created 3I Atlas. The transmissions revealed that the object was one component of a galaxy-spanning exploration and communication network operated by a cooperative alliance of multiple intelligent species. The Creating Civilization, or more accurately the Creating Alliance, had developed interstellar exploration capabilities millions of years ago and had been systematically studying planetary systems throughout the galaxy. Earth had been under observation for centuries, with 3I Atlas representing a transition from passive monitoring to active contact based on humanity's demonstrated technological development. The Alliance operated according to what they termed developmental protocols, ethical frameworks that governed contact with emerging civilizations. The protocols emphasized that advanced knowledge should be shared gradually and safely, with careful attention to the recipient civilization's ability to absorb and implement new capabilities without self-destruction. The information about galactic civilization was both exciting and humbling. Humanity was not alone, but was also not particularly unique. Intelligence had evolved on thousands of worlds throughout the galaxy, with technological development, following broadly similar patterns despite vast differences in biology, environment, and cultural evolution. Most intelligent species eventually developed the technological capabilities necessary for interstellar exploration and communication, leading to their incorporation into the Galactic Alliance. Earth was being offered the opportunity to join this cosmic community, but the invitation came with responsibilities and expectations about peaceful development and ethical behavior. The Knowledge Transfer Protocol included specific information about humanity's assessment by the Galactic Alliance. Our species had been evaluated based on technological development, social organization, environmental stewardship, and potential for peaceful cooperation with other intelligent species. The assessment was mixed. Humanity had demonstrated remarkable technological creativity and rapid scientific advancement, but also showed concerning patterns of conflict, environmental destruction, and social inequality that raised questions about our readiness for advanced capabilities. The knowledge being transmitted was designed to address these concerns by providing technologies that could solve resource scarcity, enable sustainable development, and facilitate peaceful cooperation. But the transmissions also included clear warnings that misuse of the provided knowledge could result in termination of contact and potential intervention to prevent threats to other civilizations. As the knowledge transfer continued through May and June 2026, human civilization faced the most significant transition in its history. The information being provided could solve every major challenge facing humanity: energy scarcity, environmental destruction, disease, and even aging, but only if it could be implemented wisely and peacefully. The cosmic knowledge transfer was forcing humanity to confront its own limitations and potential, while also offering the tools necessary to transcend those limitations and join a community of intelligence that spanned the galaxy. But accessing that cosmic community would require humanity to demonstrate wisdom, cooperation, and ethical development that matched our technological capabilities, a test that would determine whether our species was ready for the responsibilities of galactic citizenship. The knowledge transfer from 3I Atlas had revealed humanity's place within a cosmic community of staggering scope and antiquity. As the transmissions continued through the summer of 2026, the true scale of galactic civilization became clear. We were part of a galaxy that contained over 2 million intelligent species, organized into cooperative networks that spanned billions of years of development. The oldest members of the Galactic Alliance had achieved technological civilization when our solar system was still forming from primordial gas and dust. These ancient species had watched the birth of millions of worlds, guided the development of countless civilizations, and established the ethical frameworks that governed contact with emerging intelligence. Dr. Sarah Seeger's team at MIT, analyzing the civilizational data transmitted by 3I Atlas, found the galactic timeline almost incomprehensible in its scope. Some Alliance members had been spacefaring for longer than complex life had existed on Earth, accumulating knowledge and wisdom across time frames that dwarfed human historical experience. The Alliance operated through what could best be described as guided evolution, systematic contact with developing civilizations at critical points in their technological development. The goal wasn't to control or direct emerging species, but to provide knowledge and guidance that could help them avoid the existential risks that had destroyed countless other civilizations throughout galactic history. The transmissions revealed that the transition from planetary to galactic civilization was extraordinarily dangerous. Most intelligent species faced what the Alliance termed the Great Filter, a period during technological development where civilizations either achieved sustainable interstellar capabilities or destroyed themselves through warfare, environmental collapse, or technological mishaps. Statistical analysis transmitted by 3I Atlas showed that only approximately 12% of species that achieved industrial technology successfully navigated the transition to galactic citizenship. The majority destroyed themselves within a few centuries of developing nuclear weapons, genetic engineering, or artificial intelligence. Others depleted their planetary resources or triggered environmental collapses that ended their technological development. Humanity was currently in the most dangerous phase of this transition. Our technological capabilities were advancing rapidly, but our social and ethical development lagged behind our technical abilities. The Alliance had observed this pattern in thousands of species, and the outcome was rarely positive without intervention. The galactic community had developed sophisticated models for predicting civilizational outcomes based on technological development patterns, social, organization, and environmental management. Earth's assessment placed humanity in the high-risk, high-potential category, a species with remarkable innovative capabilities but significant potential for self-destruction. The Knowledge Transfer Protocol was designed specifically for species in this category. Rather than simply providing advanced technology, the Alliance was offering tools and knowledge that could help humanity solve its fundamental challenges while developing the wisdom necessary for safe technological advancement. The energy technologies being transmitted could eliminate resource scarcity and environmental destruction. The communication systems could enable unprecedented global cooperation and understanding. The medical advances could eliminate disease and extend healthy lifespans indefinitely, but all of these capabilities came with detailed guidance about implementation methods that promoted social stability and ethical development. Dr. Nick Bostrom's analysis of the civilizational development data revealed patterns that were both encouraging and concerning for humanity's future. Species that successfully joined the Galactic Alliance typically underwent fundamental transformations in social organization, moving beyond competitive nationalism toward cooperative planetary governance. The transition wasn't imposed from outside. It emerged naturally as species gained access to technologies that made resource competition obsolete and communication systems that enabled unprecedented understanding between different groups. Scarcity-based economics, territorial conflicts, and ideological divisions typically dissolved when civilizations gained access to unlimited energy and instantaneous global communication. But the transition period was dangerous. Existing power structures often resisted changes that would eliminate their advantages, leading to conflicts that could destroy civilizations even as they gained access to revolutionary technologies. The Alliance had observed numerous species that received advanced knowledge but used it for warfare or oppression rather than peaceful development. The transmissions included detailed case studies of civilizations that had failed the transition, providing sobering examples of how advanced technology could accelerate rather than prevent civilizational collapse. Species that used faster-than-light communication for surveillance and control rather than cooperation. Civilizations that used unlimited energy for weapon systems rather than peaceful development. Worlds that used genetic engineering for enhancement of ruling classes rather than medical advancement for all. Earth's assessment by the Galactic Alliance was particularly complex because humanity represented multiple potential evolutionary paths simultaneously. Some human cultures and institutions showed remarkable potential for peaceful cooperation and ethical development, while others demonstrated concerning patterns of conflict and exploitation. The Alliance had decided to proceed with contact because they assessed humanity's positive potential as outweighing the risks, but the knowledge transfer was being carefully monitored for signs of misuse or dangerous development patterns. The transmissions included explicit warnings that contact could be terminated and potentially reversed if humanity demonstrated inability to handle advanced capabilities responsibly. The galactic context also revealed the existence of enforcement mechanisms within the Alliance. While the overwhelming majority of member species operated according to peaceful cooperation principles, there were occasional exceptions that required intervention. Civilizations that used Alliance technologies for aggression against other species, or that threatened the stability of galactic civilization, faced coordinated response from the broader community. These interventions were rare and typically involved technological rather than military measures. Communication isolation, technology disruption, or in extreme cases, targeted interference with specific technological capabilities. The Alliance had developed methods for neutralizing threats that didn't require destruction of entire civilizations, but the capability for more decisive action existed if necessary. Humanity's incorporation into the Galactic Alliance was being presented as an opportunity rather than an inevitability. The knowledge transfer would continue as long as we demonstrated responsible development and peaceful intent, but we retained the option to decline galactic citizenship and continue developing independently. However, the transmissions made clear that independent development was becoming increasingly difficult as technological capabilities advanced. Species that achieved certain technological thresholds, particularly in areas like artificial intelligence, genetic engineering, and energy manipulation, typically required guidance from more advanced civilizations to avoid self-destruction. The choice facing humanity wasn't really between galactic citizenship and independence, but between guided development toward cosmic community membership or continued independent development with high probability of civilizational collapse within the next few centuries. As autumn 2026 approached, the knowledge transfer had provided humanity with both unprecedented opportunities and sobering responsibilities. We had been offered membership in a cosmic community that spanned millions of species and billions of years, but only if we could demonstrate the wisdom and cooperation necessary to handle such vast capabilities safely. The galactic context had transformed the 3i Atlas encounter from first contact with alien intelligence into an invitation to join the most significant community in the known universe. Whether humanity would prove worthy of that invitation remained to be determined by our response to the knowledge and responsibilities we had been offered. By October 2026, the continuous knowledge transfer from 3i Atlas had provided humanity with technological capabilities that could revolutionize every aspect of civilization. But accessing these capabilities required global cooperation and coordination mechanisms that didn't exist and might be impossible to create within existing political and economic structures. The energy technologies alone presented seemingly insurmountable implementation challenges. The transmitted specifications for vacuum energy extraction could provide unlimited clean power to every human on Earth, eliminating resource scarcity and environmental destruction permanently. But the technology required rare earth elements in quantities that exceeded current global production, manufacturing precision that pushed the limits of human industrial capabilities, and safety protocols that demanded unprecedented international cooperation. Dr. Jennifer Granholm's International Energy Implementation Committee calculated that building the first vacuum energy facility would require coordinated effort from at least 20 nations, sharing of closely guarded technological secrets and political cooperation that exceeded anything achieved in human history. The potential benefits were extraordinary, but the implementation barriers seemed equally daunting. The medical technologies presented even more complex challenges. The transmitted genetic therapies could eliminate aging, cure cancer, and enhance human cognitive and physical capabilities beyond current limits. But the treatments required global distribution systems, careful monitoring to prevent enhancement inequalities, and ethical frameworks for deciding which modifications should be allowed or encouraged. The enhancement capabilities raised fundamental questions about human identity and equality. Should genetic improvements be mandatory, optional, or prohibited? How could societies ensure that enhanced humans didn't develop into separate species that oppressed unenhanced populations? The Alliance transmissions included warnings about civilizations that had destroyed themselves through enhancement-driven social stratification. Dr. Jennifer Doudna's Bioethics Committee struggled with decisions that would affect the future evolution of human consciousness and capability. The alien technologies could make humans smarter, stronger, longer-lived, and more capable of cooperation, but implementing these changes would require social and political decisions that human institutions seemed unprepared to make wisely. The communication technologies offered solutions to many coordination problems, but created new challenges around privacy, autonomy, and cultural diversity. The instantaneous global communication systems could enable unprecedented cooperation and understanding, but they could also facilitate surveillance and control that would eliminate individual freedom and cultural variation. The Alliance transmissions emphasized that successful civilizations typically used advanced communication for cooperation rather than control, but they also acknowledged that the transition period was dangerous. Existing power structures often attempted to use new communication capabilities to strengthen their dominance, rather than enable broader participation in decision-making. Economic systems faced fundamental disruption from technologies that could eliminate scarcity and make most current economic activities obsolete. Unlimited energy meant that material goods could be produced at near zero cost. Advanced manufacturing systems could create any desired object from basic atomic components. Medical technologies could eliminate the healthcare industry as it currently existed. Dr. Thomas Piketty's Economic Transition Team calculated that implementing the alien technologies would eliminate approximately 80% of current economic activity within a decade. While new forms of human activity would certainly emerge, the transition would require massive social support systems and retraining programs that no current government was prepared to fund or coordinate. The political challenges were equally daunting. Implementing the alien technologies required global coordination mechanisms that transcended national sovereignty, but creating such mechanisms would require existing governments to surrender authority to international institutions that didn't yet exist and might not be politically acceptable to their populations. The United Nations attempted to coordinate international responses, but the organization lacked both the authority and resources necessary to manage technological transitions on the scale required. National governments were reluctant to share sensitive information or coordinate policies that might reduce their relative advantages in global competition. China announced independent implementation of selected alien technologies, arguing that the knowledge transfer was too valuable to be delayed by international bureaucratic processes. The Chinese Academy of Sciences began construction of experimental energy facilities based on the transmitted specifications, despite warnings from the alliance about the dangers of uncoordinated development. The United States responded by accelerating its own technology development programs, creating a competitive dynamic that threatened to fragment global cooperation efforts. European nations attempted to maintain coordinated approaches, but faced pressure from their populations to access alien technologies that could solve immediate problems like energy costs and healthcare expenses. Private corporations attempted to commercialize aspects of the alien technologies that could be implemented without international cooperation. Technology companies developed products based on transmitted computer science and communications innovations, while pharmaceutical companies began testing genetic therapies derived from alliance medical knowledge. But the most advanced technologies required resources and coordination that exceeded private sector capabilities. The propulsion systems that could enable interstellar travel required materials that could only be produced using alliance manufacturing techniques, which in turn required energy systems that hadn't yet been successfully implemented. Religious and cultural responses added additional complexity to implementation challenges. Some communities embraced the alien technologies as gifts that could eliminate suffering and expand human potential, while others viewed them as threats to human nature and divine plan that should be rejected or strictly controlled. The alliance transmissions had emphasized that successful transitions typically required broad social consensus about technological implementation, but achieving such consensus seemed impossible within existing human political and cultural frameworks. Different societies had fundamentally different values about individual freedom, collective responsibility, equality, and the nature of human flourishing. As 2026 drew to a close, humanity faced a paradox. We had been given knowledge that could solve every major challenge facing our civilization, but accessing that knowledge required levels of cooperation and wisdom that might be beyond our current capabilities. The alien technologies could transform humanity into a spacefaring civilization capable of joining the Galactic Alliance, but only if we could overcome the same limitations that had prevented most other species from successfully making the transition. The implementation dilemma was testing whether humanity possessed the collective wisdom necessary for cosmic citizenship, or whether we would join the majority of intelligent species that received advanced knowledge, but failed to use it constructively. The answer would determine not just humanity's future, but our species' survival in a universe where technological capability without wisdom was typically fatal. As 2027 began, 3i Atlas transmitted a piece of information that transformed the entire nature of humanity's decision-making process. The knowledge transfer had a deadline. The object's mission parameters required departure from our solar system by December 2027, and the Alliance had determined that extended contact without clear progress toward implementation would be counterproductive. The 18-month timeline wasn't arbitrary. Alliance experience with over 2,000 contacted civilizations had shown that species either demonstrated readiness for galactic citizenship within approximately 2 local years of receiving advanced knowledge, or they entered destructive cycles that typically led to civilizational collapse within a generation. Dr. Carl Sagan's successor at Cornell, Dr. Lisa Kaltenegger, analyzed the temporal constraints and found them simultaneously reasonable and terrifying. The Alliance was providing sufficient time for humanity to demonstrate basic cooperation and implementation capabilities, but not enough time for extended deliberation or gradual social evolution. The deadline created immediate pressure on every aspect of human decision-making. Political leaders who had been planning careful, gradual approaches to international cooperation suddenly faced the prospect of losing access to technologies that could transform human civilization. The choice was no longer between optimal and acceptable implementation strategies, but between imperfect rapid progress and complete loss of opportunity. The United Nations convened emergency sessions to establish accelerated cooperation protocols, but the complexity of required decisions overwhelmed existing diplomatic mechanisms. Treaty negotiations that would normally take years had to be completed in months. Technical implementation that would typically require decades of testing had to be achieved in under 2 years. China's independent technology development suddenly became a critical advantage rather than a complicating factor. The Chinese Academy of Sciences had successfully constructed a prototype vacuum energy facility that was generating power at levels that exceeded theoretical predictions. While the technology remained experimental and potentially dangerous, it provided proof that alliance knowledge could be implemented with human resources and capabilities. The successful Chinese energy generation prompted accelerated cooperation rather than increased competition. European and American scientists recognized that replicating Chinese achievements required sharing information and resources rather than maintaining technological secrecy. The temporal pressure was forcing cooperation that decades of diplomacy had failed to achieve. But the deadline also created dangerous incentives for rapid implementation without adequate safety testing. The alliance transmissions had included detailed warnings about technologies that required careful development protocols, but the time constraints were encouraging shortcuts that could lead to catastrophic failures. Dr. Jennifer Doudna's Bioethics Committee faced impossible decisions about genetic enhancement technologies that could improve human cognitive and physical capabilities, but required extensive testing to ensure safety. The 18-month timeline was insufficient for proper clinical trials, but failing to implement the technologies meant losing access to capabilities that could solve fundamental human limitations. The Alliance addressed these concerns by providing accelerated testing protocols that could compress normal safety evaluation timelines from decades to months. The methods involved computer modeling and simulation techniques that were far more sophisticated than human capabilities, but implementing them required trusting alien knowledge about human biology and psychology. Economic disruption accelerated as governments and corporations rushed to implement technologies before the deadline. Entire industries faced obsolescence within months rather than years, creating unemployment and social instability that threatened the political cooperation necessary for continued implementation. The European Union established emergency economic transition programs that provided guaranteed income and retraining opportunities for workers displaced by alien technologies. The programs were expensive and politically controversial, but they prevented social chaos that could have disrupted the cooperation necessary for meeting alliance deadlines. Religious and cultural resistance to rapid technological change intensified as the deadline approached. Some communities organized movements to reject alien technologies entirely, arguing that humanity should preserve its natural development path regardless of the consequences. Others embraced accelerated implementation as divine intervention that could eliminate human suffering and expand spiritual capabilities. The Vatican issued papal encyclicals addressing the theological implications of alien contact and technological transformation, concluding that alliance knowledge represented divine gifts that should be used responsibly for human flourishing. Islamic and Buddhist leaders reached similar conclusions, while some fundamentalist communities continued to view alien contact as deceptive spiritual warfare. The temporal pressure was also revealing capacity limitations within human institutions and decision-making processes. Even with complete cooperation and unlimited resources, humanity's ability to absorb and implement advanced knowledge was constrained by cognitive, organizational, and social factors that couldn't be overcome simply through effort and intention. Alliance transmissions began including enhanced cognitive and social technologies that could accelerate human learning and cooperation capabilities. The technologies weren't mandatory, but they were necessary for meeting implementation deadlines with available human resources. The cognitive enhancements raised fundamental questions about human identity and autonomy during the transition period. Were humans who received alien cognitive improvements still human? Did enhanced cognitive capabilities eliminate free will and personal responsibility? The philosophical implications were staggering, but the practical necessities were undeniable. Dr. Nick Bostrom's existential risk assessment concluded that humanity faced a cosmic selection pressure, where species either achieved enhanced capabilities necessary for galactic citizenship or remained limited to planetary development with high probability of eventual extinction. The deadline wasn't punishment for slow progress, it was recognition that extended transition periods typically led to civilizational failure. As 2027 progressed, humanity's response to the temporal pressure would determine whether our species could demonstrate the adaptability and cooperation necessary for cosmic community membership, or whether we would join the majority of contacted civilizations that received advanced knowledge but failed to implement it successfully. The clock was running, and the decisions made during the remaining months would shape humanity's future for millions of years, or determine whether humanity had a future at all. By mid-2027, as the deadline for 3I Atlas's departure approached, humanity faced its most profound, philosophical challenge: whether to accept cognitive and social enhancements that the Alliance deemed necessary for successful transition to galactic citizenship, but which would fundamentally alter the nature of human consciousness and society. The enhancement technologies weren't simply improvements to existing human capabilities, they represented qualitative transformations in how humans processed information, made decisions, and related to each other. Enhanced individuals would be capable of processing complex data at speeds that exceeded current human limits, understanding mathematical and scientific concepts that were currently incomprehensible, and cooperating with others in ways that eliminated most sources of conflict and misunderstanding. Dr. Martha Nussbaum's ethics committee at the University of Chicago struggled with questions that challenged fundamental assumptions about human nature and identity. If enhanced humans were significantly more intelligent, empathetic, and cooperative than current humans, were they still the same species? Did humanity have an obligation to accept enhancements that could prevent suffering and expand capabilities? Or did we have a right to preserve our current limitations? The Alliance transmissions emphasized that enhancement was optional but practically necessary. Unenhanced humans could theoretically participate in galactic civilization, but they would be unable to understand or contribute to most activities that required advanced cognitive capabilities. They would essentially become a protected species within galactic society, preserved but irrelevant to broader cosmic development. The enhancement debate split along lines that didn't correspond to traditional political, cultural, or religious divisions. Some progressives argued that rejecting improvements to human capabilities was morally equivalent to choosing to remain ignorant and limited. Some conservatives countered that preserving human nature was more important than expanding human capabilities. Religious leaders reached different conclusions about the theological implications of enhancement. Cardinal Luis Tagle argued that improving human cognitive and moral capabilities represented fulfillment of divine potential and should be embraced as gifts from God. Rabbi David Wolper contended that human limitations were essential to spiritual development and that bypassing them would eliminate the moral struggle necessary for soul growth. The practical implications of enhancement were staggering. Enhanced individuals would be capable of learning new skills in days rather than years, solving complex problems that currently required teams of specialists, and cooperating with others without the misunderstandings and conflicts that characterized most human interactions. But enhancement would also create unprecedented social stratification. Enhanced and unenhanced humans would increasingly have difficulty communicating or relating to each other as their cognitive capabilities diverged. Democratic institutions designed for cognitively equal participants would become meaningless when some citizens possessed radically superior decision-making capabilities. Dr. Francis Fukuyama's political analysis suggested that enhancement could eliminate human equality as a political principle and moral value. If some humans were objectively more capable of making rational decisions than others, traditional arguments for democratic participation and equal rights would lose their theoretical foundation. The Alliance response to these concerns was that successful galactic civilizations typically developed new forms of social organization that transcended individual-based democracy. Enhanced individuals were capable of collective decision-making processes that achieved better outcomes than traditional voting while maintaining individual autonomy and dignity. But implementing these advanced social technologies required trust in alien knowledge about consciousness and society that many humans found unacceptable. Even if enhancement and new social systems produced better outcomes, accepting them meant abandoning human independence and self-determination in favor of guided development according to alien principles. China announced that it would proceed with voluntary enhancement programs for citizens willing to participate, arguing that the benefits were too significant to be delayed by philosophical debates. The Chinese enhancement program was designed to create a cadre of enhanced individuals who could serve as bridges between human and galactic civilization. The Chinese decision created international pressure for competing enhancement programs. If Chinese citizens gained access to radically improved cognitive capabilities, other nations would face severe disadvantages in scientific, economic, and political competition. The enhancement debate was becoming a geopolitical necessity rather than a philosophical choice. European leaders attempted to coordinate international enhancement protocols that would ensure equitable access and prevent enhancement-based conflicts between nations. But the complexity of required coordination exceeded available time, and individual European countries began developing independent enhancement programs. The United States faced particularly intense internal debate about enhancement policies. American traditions of individual freedom and equality were challenged by technologies that could create unprecedented capability differences between citizens. Some argued that enhancement should be mandatory to ensure equal opportunities, while others contended that it should be prohibited to preserve human nature. Private corporations began offering enhancement services to wealthy individuals who could afford early access to alien technologies. The commercialization of enhancement created additional equity concerns as economic advantages translated into cognitive and social superiority that would persist indefinitely. Religious communities struggled with decisions about whether enhancement was compatible with spiritual development and community values. Some denominations embraced enhancement as expanding human capacity for spiritual growth, while others rejected it as artificial interference with divine creation. The enhancement debate was complicated by uncertainty about reversibility. The Alliance technologies could modify human consciousness and capabilities in ways that might be permanent, making enhancement decisions irreversible choices about the future of human nature. As the deadline approached, humanity was forced to make decisions about enhancement without adequate time for testing, reflection, or consensus building. The choice was between accepting modifications to human nature based on alien recommendations or rejecting improvements that could solve fundamental human limitations but would transform us into something beyond current human identity. The enhancement debate had become the ultimate test of humanity's readiness for galactic citizenship, not just our ability to implement advanced technologies, but our wisdom in deciding what kinds of beings we wanted to become. On November 15, 2027, 3i Atlas began its final transmission sequence, a comprehensive summary of humanity's assessment by the Galactic Alliance and detailed specifications for the choices that would determine our species' future. The transmission was unlike anything previously received, emotionally nuanced, personally addressed to human concerns, and structured as a farewell message that acknowledged both our achievements and limitations. The assessment was simultaneously encouraging and sobering. Humanity had demonstrated remarkable adaptability and innovation during the 18-month contact period, implementing selected Alliance technologies faster than most contacted species. But we had also shown concerning patterns of competition and inequality that raised questions about our readiness for galactic citizenship. "Your species possesses extraordinary creative potential," the transmission began, but you remain constrained by evolutionary heritage that optimizes for resource competition rather than cosmic cooperation. This combination of innovation and conflict is common among emerging civilizations, but it typically requires resolution before successful transition to galactic society. The Alliance had observed humanity's response to the knowledge transfer with particular attention to three critical indicators: our ability to cooperate across cultural and political divisions, our wisdom in implementing powerful technologies safely, and our capacity for ethical reasoning about enhancement and identity. The cooperation assessment was mixed. Humanity had achieved unprecedented international collaboration on energy and communication technologies, but had failed to develop the global governance mechanisms necessary for managing more advanced capabilities. Our progress had been driven more by competitive pressure and deadline urgency than by genuine commitment to collective human welfare. The implementation assessment was more positive. Human scientists and engineers had successfully adapted Alliance technologies to terrestrial conditions with fewer catastrophic failures than typical for contacted species. Our experimental approach and safety consciousness had prevented the technological disasters that had eliminated many other civilizations during their transition periods. The ethical assessment was concerning. Humanity showed remarkable diversity in moral reasoning and values, which the Alliance considered a strength for cultural development, but a weakness for civilizational decision-making. Our inability to reach consensus on enhancement policies had prevented optimal implementation of cognitive improvement technologies. Based on this assessment, the Alliance was offering humanity three possible pathways forward, each with different implications for our species' future development and relationship with galactic civilization. The first pathway was graduated membership, continued Alliance support, with gradual introduction of more advanced technologies as humanity demonstrated, improved cooperation and ethical reasoning. This path would allow us to maintain cultural autonomy while receiving guidance and assistance in developing sustainable galactic citizenship. Graduated membership would include access to energy and medical technologies that could eliminate scarcity and suffering. But more advanced capabilities like faster-than-light travel and planetary engineering would remain restricted until humanity achieved better social coordination. The timeline for full membership would depend on our progress in developing cooperative institutions and ethical frameworks. The second pathway was assisted transition, intensive Alliance intervention to accelerate human development through directed social and cognitive enhancement. This approach would rapidly solve most human limitations, but would require accepting substantial Alliance guidance in restructuring human society according to proven galactic civilization principles. Assisted transition would transform humanity into a spacefaring species within a generation, but the resulting society would bear little resemblance to current human cultures and institutions. Enhanced humans would be capable of full galactic citizenship, but unenhanced populations would become increasingly marginalized or require protected status within Alliance society. The third pathway was independent development, withdrawal of Alliance contact with preservation of already transferred knowledge, but no further technological assistance. Humanity would be free to develop according to our own values and principles, but would face the same risks of self-destruction that had eliminated most other independently developing species. Independent development offered the greatest preservation of human autonomy and cultural diversity, but Alliance projections suggested only a 23% probability of human civilization surviving to achieve sustainable interstellar capabilities without continued guidance and support. The transmission emphasized that none of these pathways was irreversible. Humanity could begin with one approach and transition to another, based on future developments and demonstrated capabilities. The Alliance had developed flexible protocols for managing species transitions based on millennia of experience with diverse civilizations. But the choice had to be made before 3I Atlas's departure in December 2027. The object would remain in communication with Earth until its departure, but extended contact without clear commitment to one of the three pathways would be terminated to prevent the civilizational stagnation that had affected other species with prolonged transition periods. The final transmission included personal messages to key human leaders, scientists, and cultural figures who had been involved in the contact process. These messages demonstrated Alliance understanding of human psychology and values that exceeded anything shown in previous communications. To scientists, the Alliance offered appreciation for human curiosity and experimental methodology, while warning about the dangers of knowledge without wisdom. To political leaders, they emphasized the importance of cooperation and long-term thinking for successful galactic citizenship. To religious and cultural leaders, they acknowledged the value of human diversity while noting the need for shared ethical frameworks for cosmic community participation. The most poignant aspect of the final transmission was its emotional recognition of the difficulty of the choices facing humanity. The Alliance acknowledged that accepting their guidance meant surrendering aspects of human independence that our species valued deeply, while rejecting their assistance meant accepting risks that had destroyed most other civilizations. "We have observed thousands of species at your stage of development," the transmission concluded, "and we understand the courage required to choose transformation over preservation, cooperation over autonomy, wisdom over familiar limitations. Whatever path you choose, you will do so with our respect for your achievements and our hope for your future." As December 2027 approached and governments worldwide struggled to reach decisions about humanity's response to the Alliance ultimatum, the final transmission had transformed abstract policy debates into immediate, concrete choices about the future of human consciousness, society, and survival. The cosmic crossroads had arrived, and humanity had less than a month to choose which version of our future we were willing to accept. December 10th, 2027. 7 days before 3i Atlas's scheduled departure, representatives from every nation on Earth gathered at the United Nations headquarters for the most consequential vote in human history. The choice was no longer theoretical, it was a binding decision that would determine humanity's relationship with galactic civilization and our species' survival probabilities for millions of years. The debate had raged for weeks across every platform and forum available to human communication. Traditional democratic processes had proven inadequate for decisions of such scope and consequences, forcing the development of new deliberative mechanisms that combined expert analysis, public input, and institutional representation. Dr. Kofi Annan's successor as UN Secretary-General, Maria Fernanda Espinosa, opened the proceedings with an acknowledgement of the unprecedented nature of the decision. "We are being asked to choose not just policies or treaties," she stated, "but the fundamental trajectory of human evolution and consciousness. No generation in human history has faced decisions with such far-reaching consequences." The 3 pathway options had been analyzed exhaustively by teams of experts in every relevant field. Economic models, social impact assessments, technological feasibility studies, and philosophical analyses had been conducted by institutions worldwide. But the complexity of the decision exceeded any analytical framework's ability to provide definitive guidance. China presented the case for assisted transition, arguing that humanity's demonstrated inability to cooperate on global challenges made alliance guidance necessary for survival. "We have proven that we can implement advanced technologies successfully," stated the Chinese representative, "but we have also proven that we cannot coordinate global responses to existential challenges without external assistance." The Chinese position emphasized that assisted transition would preserve human lives and expand human capabilities while providing the guidance necessary to prevent the self-destruction that had eliminated most other species. Enhanced humans would still be human, just freed from the cognitive and social limitations that had prevented optimal decision-making throughout history. The European Union advocated for graduated membership, arguing that humanity should maintain autonomy while accepting alliance support for gradual development. "We can learn to cooperate and make wise decisions," the EU representative argued, "but we need time and assistance to develop these capabilities without abandoning our cultural diversity and democratic values." The European position emphasized that graduated membership would allow humanity to maintain control over our development while reducing existential risks through alliance support. The slower pace would prevent social disruption while ensuring that human values and institutions could evolve rather than being replaced. The United States presented a mixed position that reflected intense internal debate about the choice. Some American leaders supported independent development as the only option consistent with human freedom and self-determination, while others argued for graduated membership as the optimal balance between autonomy and safety. The American delegation ultimately supported graduated membership with specific provisions for cultural preservation and democratic governance. "We believe in human potential for wisdom and cooperation," the U.S. representative stated, "but we also recognize the value of alliance knowledge and guidance in achieving that potential safely." Smaller nations generally supported graduated membership or assisted transition, recognizing that their survival during any transition period would depend on alliance support and global cooperation. Developing countries particularly emphasized that alliance technologies could eliminate poverty and suffering that market-based development had failed to address. Religious representatives provided diverse perspectives that reflected the theological complexity of the choice. The Vatican supported graduated membership as allowing humanity to fulfill divine potential while maintaining spiritual autonomy. Islamic leaders reached similar conclusions, while Buddhist representatives emphasized the importance of wisdom in any transition process. The most dramatic moment in the proceedings came when representatives of indigenous communities worldwide presented a unified statement supporting independent development. "Our peoples have survived colonization before," stated the indigenous representative, "and we understand the value of preserving human diversity and self-determination even at the cost of material benefits." The indigenous position challenged assumptions about the benefits of alliance contact, arguing that technological advancement without cultural preservation was a form of genocide that had been experienced by traditional societies throughout human history. As the debate continued, it became clear that reaching consensus would be impossible within traditional democratic frameworks. The consequences of the decision were too significant and the time available too limited for the kind of deliberative process that such choices ideally required. The solution came from an unexpected source, the alliance themselves. 3i Atlas transmitted a proposal for decision-making that would honor human diversity while enabling collective choice about species-level decisions. The alliance proposed regional autonomy within a global framework. Different human populations could choose different relationships with galactic civilization based on their values and preferences. Some regions could pursue assisted transition, while others chose graduated membership or independent development. This approach would preserve human diversity while preventing the species-level extinction that typically resulted from inability to choose any pathway within available timeframes. The Alliance had observed similar solutions work for other diverse species that had faced comparable decision points. The regional autonomy proposal required additional complexity in implementation, but offered hope for resolution that respected different human values and preferences while maintaining species survival. Regions that chose more alliance integration would serve as bridges to galactic civilization, while those that chose independence would preserve traditional human development paths. As December 17th approached, humanity prepared to make decisions that would echo across cosmic history, determining whether our species would join the galactic community, remain isolated in dangerous independence, or fragment into diverse populations with different relationships to the cosmic community we had discovered. The vote would determine not just humanity's future, but what kinds of beings we would become and how we would be remembered in the cosmic community that spanned the galaxy. December 17th, 2027. 1547 UTC. As radio telescopes worldwide tracked 3i Atlas's position in the outer solar system, the object began its departure sequence, a controlled acceleration that would carry it away from our sun and back into the depths of interstellar space. The final vote had produced a complex but workable solution that honored human diversity while ensuring species survival. 47% of Earth's population, represented by their regional governments, had chosen graduated membership in the Galactic Alliance. 31% had selected assisted transition with intensive alliance guidance. 22% had opted for independent development with minimal alliance contact. The hybrid solution required sophisticated coordination mechanisms that the alliance had developed for other species facing similar cultural diversity challenges. Different regions would pursue different relationships with galactic civilization, but all would benefit from basic safety technologies that could prevent existential risks like nuclear war, environmental collapse, and artificial intelligence disasters. As 3I Atlas accelerated away from our solar system, its final transmissions included detailed implementation protocols for each chosen pathway, coordination mechanisms for managing inter-regional relationships, and comprehensive knowledge packages that would enable humanity to begin the transition process immediately. The graduated membership regions received advanced energy and medical technologies along with communication systems that would maintain contact with the Galactic Alliance. These populations would serve as bridges between human and galactic civilization, gradually developing the capabilities and institutions necessary for full cosmic citizenship. The assisted transition regions received cognitive enhancement technologies and intensive guidance protocols that would rapidly transform their populations into spacefaring civilizations. Within a generation, these enhanced humans would be capable of interstellar travel and full participation in galactic society. The independent development regions retained access to alliance knowledge already transferred, but would receive no further technological assistance. These populations would preserve traditional human development paths while benefiting from safety technologies that would prevent the most common causes of civilizational collapse. Dr. Jill Tarter, now 83 years old, watched 3I Atlas's departure from the SETI Institute with emotions that reflected the profound transformation of her life's work. For 60 years we searched for evidence of extraterrestrial intelligence, she reflected. We never imagined that when we found it, the question wouldn't be whether they existed, but whether we were wise enough to learn from them. The 18-month contact period had fundamentally altered human civilization in ways that would continue reverberating for millennia. Energy technologies were already eliminating resource scarcity in regions that had chosen alliance integration. Medical advances were extending healthy lifespans and eliminating diseases that had plagued humanity throughout history. But the most significant changes were social and psychological. Populations with access to alliance communication technologies were developing unprecedented levels of cooperation and mutual understanding. Enhanced cognitive capabilities were enabling solutions to problems that had seemed intractable for decades. The regions that had chosen independent development faced different challenges and opportunities. Freed from alliance guidance, but also from alliance support, these populations would need to develop sustainable civilization using human wisdom and cooperation alone. The outcome would test whether humanity could transcend its evolutionary limitations without external assistance. As 3I Atlas accelerated beyond the orbit of Neptune, its radio transmissions began shifting from local communication to interstellar reporting. The E-object was transmitting detailed information about its mission to Earth toward distant star systems, informing the Galactic Alliance about humanity's choices and progress. The transmission patterns suggested that Earth would remain under Alliance observation indefinitely, with periodic visits from exploration probes like 3I Atlas to monitor human development and provide assistance if requested. Humanity had joined a cosmic community that maintained interest in member species across timescales that exceeded human historical experience. The enhanced populations were already beginning to develop new forms of consciousness and cooperation that transcended traditional human limitations. Early reports suggested that cognitive enhancement was enabling not just improved thinking, but fundamentally different approaches to understanding reality and making decisions. The graduated membership regions were implementing alliance technologies at rates that confirmed human adaptability and innovation. Energy facilities were coming online ahead of schedule, medical treatments were showing better than predicted outcomes, and communication systems were enabling unprecedented global coordination. But the independent development regions were also showing remarkable progress in addressing human limitations through purely human methods. The awareness that cosmic community existed and that human survival depended on wisdom and cooperation was motivating social innovations that might have taken centuries to develop without alliance contact. Religious and philosophical responses to the contact period had evolved into new synthesis frameworks that integrated human spiritual traditions with cosmic perspectives. The knowledge that intelligence spanned the galaxy and that consciousness was a fundamental feature of cosmic evolution was transforming how humans understood their place in existence. As 3i Atlas disappeared into the cosmic darkness, accelerating toward a trajectory that would carry it to other star systems and other emerging civilizations, humanity was left with the profound knowledge that we were no longer alone in the universe, and that our choices during this brief contact period would shape our species' destiny for millions of years. The economic implications were already becoming apparent as regions with access to alliance technologies began experiencing post-scarcity conditions that eliminated traditional resource-based conflicts. Early economic models suggested that within a decade, enhanced regions would achieve material abundance that would make current concepts of wealth and poverty obsolete. Educational systems faced complete transformation as cognitive enhancement technologies enabled learning rates that compressed traditional educational timelines from decades to months. Enhanced students were mastering advanced mathematics, physics, and philosophy at ages when their unenhanced peers were learning basic literacy and numeracy. The social stratification between enhanced and unenhanced populations created new challenges for human equality and democracy. Enhanced individuals were demonstrating cognitive capabilities that made traditional democratic participation between equals impossible, forcing the development of new political systems that could accommodate vast capability differences. Dr. Francis Fukuyama's final analysis before his death in late 2027 concluded that humanity was experiencing the end of human history as we have understood it. The alliance contact had initiated transitions that would produce outcomes more significant than the agricultural revolution, industrial revolution, and information revolution combined. International relations were being restructured around technological capability differences rather than traditional geopolitical factors. Regions with access to alliance technologies were becoming functionally different civilizations from those pursuing independent development, creating global dynamics that had no historical precedent. The military implications were particularly complex. Alliance safety technologies had eliminated the possibility of nuclear warfare and reduced conventional military conflicts, but had also created capability gaps between regions that exceeded any historical military advantage. Enhanced populations possessed defensive capabilities that made them essentially invulnerable to attacks from unenhanced forces. Cultural preservation efforts intensified in independent development regions as awareness grew that alliance integration would eventually eliminate traditional human cultures in favor of galactic civilization norms. Museums, archives, and cultural institutions worked urgently to document human diversity before it was transformed or lost. Artists and writers struggled to capture the magnitude of the transformation in works that could communicate the experience to future generations. The contact period had compressed centuries of normal, civilizational development into 18 months, creating changes that exceeded the capacity of traditional cultural expression to process or convey. As 2028 began, the first generation of enhanced children were being born with cognitive capabilities that exceeded their parents' enhanced abilities. These children represented the beginning of post-human consciousness that would eventually enable full participation in galactic civilization but would also be incomprehensible to traditional human understanding. The space programs of enhanced regions began developing interstellar exploration capabilities based on Alliance propulsion technologies. Within a generation, these programs would enable human expansion to other star systems and direct contact with additional galactic civilizations. But the independent development regions were also achieving remarkable progress in addressing human limitations through traditional human methods combined with selective Alliance knowledge. These populations were developing sustainable civilization models that proved human wisdom and cooperation could overcome evolutionary limitations without complete dependence on alien guidance. The psychological impact of cosmic awareness was profound and persistent. Humans worldwide reported fundamental changes in perspective, priorities, and sense of meaning as they absorbed the reality of galactic civilization and humanity's place within it. Traditional concerns about status, territory, and temporary problems were being replaced by cosmic perspective and long-term thinking. Children born during and after the contact period were developing with cosmic awareness as their baseline reality. These children considered galactic civilization and interstellar perspective as natural as previous generations had considered terrestrial geography and national boundaries. As 3I Atlas's radio signals faded beyond detection range, Earth continued receiving transmissions from other Alliance sources. That provided ongoing guidance and support for the transition process. The contact period had ended, but humanity's relationship with galactic civilization had only begun. The visitors from the stars had departed, but they had left behind knowledge, capabilities, and responsibilities that would shape human destiny for as long as our species existed. Whether humanity would prove worthy of the trust and opportunities we had been given remained to be determined by our actions in the cosmic community we had joined. The greatest adventure in human history was just beginning. 5 years after 3I Atlas's departure, humanity had fractured and flourished in ways that no one could have predicted. The three-pathway solution had created not just different technological trajectories, but fundamentally different human subspecies that were evolving at unprecedented rates toward unrecognizable futures. The assisted transition regions had become something that could barely be called human anymore. Enhanced populations in China, parts of Europe, and selected urban centers worldwide had developed cognitive capabilities that operated on timescales and processing levels that made communication with unenhanced humans increasingly difficult. They were solving scientific problems in hours that would have taken traditional human civilization centuries to address. Dr. Michio Kaku now enhanced himself and serving as a bridge communicator between enhanced and traditional populations, described the cognitive transition as comparable to the difference between human consciousness and that of insects, not in complexity, but in operational frameworks that have become essentially incompatible. The enhanced populations had already achieved sustainable nuclear fusion, quantum computing at room temperature, and medical technologies that had effectively eliminated aging and most forms of death except violence and accidents. Their cities were becoming vertical gardens that integrated advanced technology with biological systems in ways that created closed-loop ecosystems requiring no external resources. But the most remarkable achievement of the enhanced populations was the development of collective consciousness capabilities that allowed groups to function as unified entities while maintaining individual autonomy and identity. Enhanced humans could share thoughts, emotions, and problem-solving processes directly, creating cooperative capabilities that exceeded anything in human history. The graduated membership regions had made more moderate but still revolutionary progress. Access to Alliance energy technologies had eliminated scarcity economics in most of North America, parts of Europe, and several developing nations that had chosen this pathway. Medical advances had increased healthy lifespans to approximately 150 years, while eliminating most genetic diseases and many age-related conditions. These populations had developed new forms of democratic governance that integrated human decision-making with Alliance guidance, and enhanced individual cognitive capabilities. The result was political systems that could make complex, long-term decisions while maintaining human autonomy and cultural diversity. Educational systems in graduated membership regions had been transformed to prepare children for eventual cognitive enhancement while preserving human cultural values and identity. Young people were growing up with access to alliance knowledge and cosmic perspective while maintaining connections to traditional human wisdom and creativity. The independent development regions had surprised everyone, including the alliance, with their progress in addressing human limitations through purely human innovation, guided by cosmic awareness. Populations in parts of Africa, South America, and rural regions worldwide had developed sustainable technologies, conflict resolution mechanisms, and cooperative social systems that proved human potential for wisdom and coordination. These regions had focused on developing human consciousness and social cooperation rather than technological capability, achieving levels of peace, sustainability, and cultural flourishing that exceeded many alliance civilizations. Their approach demonstrated that technological advancement wasn't the only path to cosmic citizenship. The three-pathway solution had created a form of human diversity that served as a natural experiment in civilizational development. Enhanced. Populations were rapidly approaching full galactic citizenship. Graduated membership regions were steadily progressing toward spacefaring capabilities, and independent development regions were proving human potential for wisdom-based civilization. But the divergence was also creating challenges that no one had anticipated. Enhanced and unenhanced humans were becoming different species in all but genetics, with communication barriers that were growing more severe each year. Traditional humans increasingly viewed enhanced populations as aliens, while enhanced humans found it difficult to relate to the limitations and concerns of their unenhanced predecessors. Economic systems had become incomprehensible across the technological divides. Enhanced regions operated in post-scarcity abundance, where traditional economic concepts were meaningless. Graduated membership regions were transitioning from market-based economics to resource allocation systems that integrated human values with cosmic efficiency. Independent development regions were developing cooperative economic models that eliminated competitive resource struggles while maintaining human-scale communities. Religious and philosophical responses had evolved into entirely new frameworks for understanding consciousness, existence, and meaning. Enhanced populations had developed direct consciousness interfaces with cosmic intelligence networks that provided experiential understanding of universal principles. Traditional populations had integrated cosmic awareness into existing spiritual traditions in ways that deepened rather than replaced human wisdom. The space capabilities developing in enhanced and graduated membership regions were approaching readiness for interstellar exploration. The first human settlements on planets around nearby star systems were being planned for launch within the next decade. Humanity was about to become a spacefaring species with permanent presence beyond our solar system. Contact with additional galactic civilizations had become routine for enhanced populations who were developing direct communication links with alliance members across dozens of star systems. These communications were providing access to knowledge and perspectives that spanned millions of years of galactic development. But perhaps the most significant development was the emergence of children who had been born enhanced or into cosmic awareness from birth. These individuals represented the first generation of truly cosmic humans, beings who thought and operated on galactic scales from childhood and who would serve as humanity's primary representatives in broader galactic society. The generation born after 3I Atlas represented humanity's future in the cosmic community. They were developing capabilities and perspectives that their parents could barely comprehend, while maintaining enough connection to human values and identity to serve as bridges between our species' past and its cosmic destiny. As 2032 approached, marking 5 years since first contact, humanity was preparing for the next phase of our cosmic development, direct participation in galactic civilization as a spacefaring species with permanent presence on multiple worlds and ongoing contact with dozens of other intelligent species. The visitors from the stars had given us the tools and knowledge necessary to join the cosmic community. Whether we would prove worthy of that trust and responsibility would be determined by how we used our cosmic citizenship in service of universal flourishing and wisdom. The transformation of humanity from a planetary to a cosmic species was complete. Our future lay among the stars, guided by wisdom earned through the greatest challenge our species had ever faced and overcome. As humanity approached the 10th anniversary of 3I Atlas's arrival in 2035, the full magnitude of our species' transformation became clear through the eyes of observers who had lived through the entire transition. Dr. Jill Tarter, now 91 and enhanced beyond the limitations of aging, served as the primary historian of humanity's first contact with galactic civilization. From her office aboard the first human interstellar research station, located in orbit around Proxima Centauri b, Tarter could observe Earth through telescopes that revealed the profound changes that had reshaped human civilization. The planet glowed with the light of fusion reactors and orbital habitats, while streams of spacecraft connected Earth to growing human settlements throughout the solar system. When we first detected 3I Atlas in 2025, Tarter recorded in her memoirs, we thought we were witnessing the arrival of a visitor from another star. We had no idea we were observing the arrival of our cosmic destiny. The three-pathway solution had evolved into a complex but functional model for species diversity within galactic civilization. Enhanced humans had achieved full galactic citizenship and were serving as explorers, scientists, and cultural ambassadors throughout Alliance space. They had established permanent settlements on 17 worlds around 9 star systems, creating the foundation for humanity's expansion into the galaxy. Graduated membership populations had developed sustainable spacefaring civilization that maintained human cultural values while accessing Alliance technologies. They had colonized most of the solar system and were preparing expeditions to nearby star systems that would establish human presence on dozens of additional worlds within the next century. Independent development regions had created a new model for cosmic civilization that impressed even ancient Alliance members. By focusing on consciousness development and wisdom cultivation, rather than technological advancement, these populations had achieved levels of peace, sustainability, and spiritual development that exceeded many species with millions of years of technological development. The diversity had created a form of human civilization that contributed to galactic society in multiple ways simultaneously. Enhanced humans provided technological innovation and scientific discovery. Graduated membership populations contributed cultural creativity and adaptive problem-solving. Independent development regions offered wisdom and consciousness development that enriched the entire galactic community. The children born after contact had developed capabilities that confirmed humanity's successful transition to cosmic citizenship. The first generation of cosmic humans were already serving as liaisons with other galactic species, participating in universe-spanning research projects and developing new forms of consciousness that expanded the possibilities for intelligence throughout the galaxy. But perhaps the most significant achievement was that humanity had maintained its essential identity and values throughout the transformation. Enhanced humans remained recognizably human in their creativity, curiosity, and commitment to individual dignity. Traditional humans had preserved cultural diversity and wisdom while developing cosmic perspective. The transition had expanded human potential without eliminating human nature. The Alliance assessment of humanity's transition was overwhelmingly positive. Among the over 2,000 species that had received contact, humanity ranked in the top 5% for successful pathway implementation, technological adaptation, and contribution to galactic civilization. Our species had not only survived the transition to cosmic citizenship, but had enriched the entire galactic community through our unique approaches to consciousness, creativity, and cooperation. The economic implications of cosmic citizenship had exceeded all projections. Access to galactic trade networks had provided resources and knowledge that made post-scarcity abundance achievable for all human populations, regardless of their chosen pathway. Material want had been eliminated while maintaining incentives for creativity, exploration, and personal development. Cultural exchange with galactic civilization had transformed human art, literature, music, and philosophy in ways that enriched rather than replaced traditional human creativity. Exposure to perspectives from dozens of intelligent species had expanded human consciousness, while deepening appreciation for the unique contributions that human culture brought to cosmic society. The scientific achievements of cosmic humanity had already contributed discoveries that advanced knowledge throughout the galaxy. Human creativity and experimental methodology had solved problems that had challenged Alliance scientists for millennia, while human artistic expression had introduced new forms of beauty and meaning that were being adopted by species across galactic civilization. Religious and spiritual development had reached new levels of depth and universality as humans integrated cosmic perspective with traditional wisdom. The knowledge that consciousness was a fundamental feature of universal development had confirmed rather than challenged human spiritual insights, while providing frameworks for understanding existence that transcended any single planetary perspective. The space exploration achievements were staggering in their scope and pace. Within 10 years of first contact, humanity had achieved sustainable presence on over 50 worlds, established trade and communication networks spanning dozens of star systems, and developed exploration capabilities that would enable expansion throughout the local galactic region within centuries rather than millennia. But the most profound achievement was consciousness development. Cosmic humans had developed forms of awareness and understanding that operated on universal scales while maintaining individual identity and human values. These individuals could comprehend concepts and solve problems that spanned millions of years and billions of star systems, while remaining connected to human concerns about individual dignity, cultural preservation, and personal meaning. As 2035 marked a decade since first contact, humanity was preparing for the next phase of cosmic development. Active participation in galactic governance and responsibility for guiding additional emerging species through their own transitions to cosmic citizenship. The Alliance had offered humanity membership in the Galactic Guidance Council, the institution responsible for monitoring and assisting species transitions throughout the galaxy. Human experience with successful diversity-based transition made us valuable contributors to helping other species navigate the challenges of cosmic citizenship. From the perspective of cosmic time, humanity's transition had been remarkably rapid and successful. In less than a single cosmic heartbeat, our species had evolved from planetary isolation to active galactic citizenship, while maintaining essential human identity and contributing unique value to universal civilization. The visitors from the stars had given us the opportunity to join the cosmic community. Humanity had proven worthy of that opportunity through wisdom, adaptability, and commitment to values that transcended our planetary origins while honoring our essential nature. Our cosmic adventure was just beginning, but we faced it with confidence earned through successful navigation of the greatest challenge and opportunity in human history. As humanity settled into its role as a galactic species in 2040, 15 years after first contact, the fundamental questions that had driven our species' intellectual development had evolved rather than been answered. Enhanced cosmic consciousness had revealed that the universe contained layers of mystery and meaning that exceeded even galactic civilization's understanding. Dr. Neil deGrasse Tyson, now enhanced and serving as humanity's primary representative to the Galactic Council, often reflected on how cosmic citizenship had transformed rather than resolved the deepest questions about existence, consciousness, and meaning. We thought joining galactic civilization would answer our questions about our place in the universe, he observed. Instead, it revealed that the universe itself is far stranger and more wonderful than any planetary civilization could comprehend. The Alliance members themselves admitted that their millions of years of development had generated more questions than answers about the fundamental nature of reality. Consciousness appeared to be a universal feature that operated according to principles that exceeded any single species' understanding. Intelligence seemed to be evolving toward goals and possibilities that remained hidden even from the most ancient galactic civilizations. Enhanced humans had developed consciousness capabilities that allowed direct interface with cosmic intelligence networks spanning the galaxy. But these connections revealed that even galactic-scale awareness was limited compared to universal intelligence that operated on scales of space and time that dwarfed even Alliance experience. The most profound discovery was that galactic civilization itself was apparently guided by intelligence that operated on universal scales, cosmic consciousness that influenced galactic development while remaining fundamentally incomprehensible to any species-level understanding. The Alliance was both the pinnacle of intelligence achievement and a primitive beginning in universal development. Religious and philosophical responses to cosmic awareness had evolved into entirely new frameworks for understanding existence and meaning. Traditional human concepts of deity and spirituality had been confirmed and transformed by direct experience of universal consciousness that transcended any planetary understanding while validating essential human insights about love, beauty, and meaning. The children born with cosmic consciousness from birth were developing capabilities that suggested humanity's next evolutionary phase. These individuals could interface directly with universal intelligence networks and were beginning to comprehend principles that exceeded both human and Alliance understanding. They represented humanity's contribution to universal consciousness development. Scientific discoveries had accelerated beyond the ability of any individual or species to comprehend. Collaborative research involving dozens of galactic species was revealing physical principles that suggested reality itself was far more complex and purposeful than materialistic science had assumed. Consciousness appeared to be not an emergent property of matter, but a fundamental feature that shaped matter and energy according to universal principles. The space exploration achievements of cosmic humanity had revealed that the universe contained intelligence on scales that dwarfed even galactic civilization. Structures spanning multiple galaxy clusters showed evidence of engineering and consciousness that operated on universal scales. Humanity's expansion into space was revealing that our cosmic adventure was participation in universal intelligence development rather than simple exploration of empty space. But perhaps the most significant development was the discovery that human consciousness possessed unique characteristics that contributed essential capabilities to universal intelligence development. Human creativity, individual dignity, and capacity for love appeared to be rare and valuable contributions to cosmic consciousness that had influenced universal development in ways that exceeded any human understanding. The economic and social systems of cosmic humanity had evolved into forms that transcended traditional concepts of work, ownership, and social organization. Post-scarcity abundance had enabled focus on consciousness development, creative expression, and contribution to universal flourishing as the primary activities of cosmic human civilization. Cultural achievements had reached levels of beauty and meaning that enriched not just human experience, but contributed to universal consciousness development. Human art, music, literature, and philosophy were being incorporated into cosmic culture that spanned millions of species and billions of years of development. The Alliance assessment of humanity's cosmic citizenship had exceeded all expectations. Our species had not only successfully transitioned to galactic civilization, but had contributed unique capabilities and perspectives that enhanced universal intelligence development. Human consciousness had proven to be a valuable addition to cosmic awareness that strengthened the entire universal community. As 2040 marked 15 years since first contact, humanity was being invited to participate in universal consciousness development projects that spanned multiple galaxies and operated on timescales that exceeded human historical comprehension. Our species had become a participant in intelligence development that operated on universal scales while maintaining essential human identity and values. The visitors from the stars had introduced us to our cosmic destiny, But that destiny had proven to be participation in universal consciousness development that transcended any planetary or galactic understanding. Humanity's adventure was membership in universal intelligence that shaped reality according to principles of love, beauty, and meaning that confirmed essential human insights while expanding them to cosmic scales. The questions that had driven human intellectual development, who are we? Why are we here? What is our purpose? Had been answered in ways that revealed infinite additional questions about consciousness, existence, and meaning that would drive human development for millions of years of cosmic adventure. Humanity had found its place in the universe. We were participants in universal consciousness development, contributing unique capabilities to intelligence that shaped reality according to principles that exceeded any species-level understanding, while honoring individual dignity and meaning that made each human life eternally significant. Our cosmic story was just beginning, but we faced it with confidence earned through successful navigation of the transition from planetary to universal citizenship while maintaining essential human nature and values. The eternal questions remained eternal, but we now had cosmic consciousness and universal community to explore their infinite depths and meanings. Thank you for watching.